who are sitting in the back side. And warm welcome to the IESA AI Summit 2023 Day 2, spearheaded by India Electronics and Semiconductor Association, Hyderabad chapter. I'm LPS Kumar, a project engineer at Qualcomm, responsible for executing automobile projects. Today, I'll be your host and master of ceremonies. We are delighted to meet you once again to share a series of sessions exploring the disruptive progress driven by technology. So day one was filled with insightful discussions and some key takeaways. Yesterday, the event covered the journey from AI potential to its practical implications and exploring generative AI at the edge and its impact on silicon design. It emphasized the role of AI in enabling next-gen embedded applications. The discussions also touched upon the hardware architecture, supporting deep neural networks and generative AI while highlighting the challenges and opportunities in implementing these solutions. There was a focus on developing cost-effective solutions and also power, performance, and thermal factors. So there was an opinion that Hyderabad is in a race to become the next AI capital of India. So let us shift gears now. So today's morning sessions will cover mostly automotive and healthcare, and also featuring some energetic panel discussions. So we have a keynote address coming up, Unlocking the Value of AI in Mobility by Rashmi Gopal Rao. Rashmi Gopal Rao is an automotive industry manager at MathWorks India, spearheads strategic planning and technology implementation in the region, focusing on driving industry adoption of model-based design, MATLAB, and Simulink. With over 22 years of experience, she has specialized in diesel control systems with exposure to body control, chassis, and ADAS domains. Prior to MathWorks, Rashmi has worked with ETA's Automobile India Private Limited, Maruti Suzuki India Limited, and Robot Bosch India Limited. She holds a bachelor's degree from Ramaya Institute of Technology and an executive management degree from IIM Calcutta. Please welcome Rashmi Gopal Rao.
Good morning, Hyderabad. Can you hear me? Okay.
Good morning.
Thank you. Let's try that once more. Good morning, Hyderabad. So welcome to the first session of the day. And I think like my introduction said, I've spent my entire career in automotive, right? So whatever you're going to see here is the automotive view of why semiconductors are going to play a very important role in the next wave of mobility, in the next generation of mobility, right? There are not a lot of keynotes that start with a cartoon, but I found this basically a clip from Dilbert to be something interesting to sort of share my thoughts when I started working on AI in the automotive industry, right? So this clip is actually from 2016, and in my career, I started talking about AI probably around the same time, 2016, 17, and for a lot of us, AI was very vague. Right? Where do you put it? How do you use it? Is this even real? Right? So for me, really this clip captured the skepticism as an automotive industry when we talked about AI. But I'm happy to say, and probably that's why I'm here, that the picture has changed dramatically a few years down the lane. So today in my talk, I'd like to share my experience about the transformation that the auto industry is facing, right? And I'm sure you'll hear much more from veterans who are going to talk about this in the panel discussion after this talk. So we'll take a quick look at what is this transformation that is happening. I'd also like to talk about two very important drivers or backbones in this transformation. So the first is data, and that's being called basically the new gold. It's a cliche, you've heard it, but let's talk a little bit about that. And then let's also connect that data with the infrastructure that you need of the cloud and look at what kind of possibilities are possible and what is happening in the industry. I would also like to share in the next section after that how AI is being used today in the automotive industry, right? So let's take a look from, of course, my lens will be the MathWorks lens, but I'll try to share a few of the use cases on how the automotive industry is essentially using AI. And then we'll take a look at what can be the opportunities to come, right? Both as the automotive industry and as the semiconductor industry. What are the opportunities to come? What kind of use cases we can look at? How do we really unlock the value of AI together? So let's get started. How many people in the room have heard that automotive is undergoing a transformation? Raise of hands. Great, so you've made my job easy, right? I don't need to go through this slide. But essentially, the industry is now moving from very mechanical-centric industry, right? We were proud about our engines, we were proud about our suspensions, we were proud about our injection timing, everything mechanically oriented. But we are moving away from that to essentially look at how we can use software to define the vehicle, and hence the term basically the software-defined vehicle. Customers today are demanding a cleaner mobility, and that's why you're hearing so much about electrification. In a country like India, where we lose 150,000 people on the roads every year, we are demanding safer mobility. How can we basically use software to make our mobility safe? We are also demanding a sort of a digital life continuity. When we walk in with our fancy phones and our devices into the phone, we want a connected and a continuous experience once we enter our cars, right? So this is basically the customer expectations. Along with that, we have the mega trends of electrification, we have the mega trends of autonomous driving. We are seeing an enormous enhancement in the compute capability that helps us as an industry to introduce so much more features, right? And also the connectivity to the cloud. And we'll talk a little bit about it in my next slide, right? Apart from that, for an automotive industry that's basically looking at how they can continually improve their profits, the opportunity that you can have a vehicle that can enhance even after it has rolled out of the shop floor, right? You can provide features to the customers driving your car. You can have subscription kind of use cases to the customers driving the car, and somewhat become like a cell phone industry. Now that opportunity for the automotive world is extremely enticing, and that's basically the third point I talk about when I talk about business opportunity. So these three things largely are defining why we as an automotive industry are moving more and more towards software. And very loosely today at MathWorks, we define a software-defined vehicle as a vehicle where the main value is essentially coming from software, right? So that's a software-defined vehicle. Let's take a moment and look at this rush for data. Why is there this rush for data? So this is a very interesting graphic from McKinsey. Now, if you look at the chart on the right side and 2030, McKinsey actually predicts that a car OEM can make as much or maybe even more revenue than just from selling cars, but by subscription services, value-driven services, software that can be downloaded onto the car, right? So that's basically the first big driver for why data is becoming so important when we work with cars. The second reason OEMs is looking at basically data is also to improve their R&D, right? So the field data can help them to understand customer behavior better so they can design better products. They can also use that data to reduce their costs. For example, warranty costs. Now this is a big cost for OEMs. So if they have better data, if they have features in place where they can reduce downtimes, reduce warranty costs, this is a big business opportunity for them. And I think the third reason or the third factor why companies are looking at data is also to increase the safety and the security. For me, it's personally for me a great driver, right? To make our cars safer when there's a crash, to improve the time an emergency service can reach basically the customer, right? And things like driver monitoring systems, right? How many of us have sat in cabs where the driver is drowsy, right? What if we can have better monitoring systems to improve the safety of mobility? So these are the reasons why data and the data that is being generated from the vehicle is becoming very, very important for us to look at as an industry. Now, going hand in hand with data, and that's why I kind of coined the term data with cloud, right, is sort of the new gold, is the infrastructure and the compute that we need to handle this big data. And that's also making enormous strides. So today, automotive is looking at the cloud as extra compute, right? So I have so much compute on the car, but I can demand and I can scale off-board compute. Now that again opens up a lot of opportunities for us. The second is, for many of you who are from automotive here, and I'm guessing it is somewhat an automotive audience, we were very happy with our good old V cycle, right? Requirements to validation to calibration. But that's just not enough if you have to play the software game. We have to learn to adopt processes like agile, like continuous integration, like continuous development, and so on, so that we can the turnaround of software, the time that we take is dramatically reduced. And of course, over-the-air updates. I spoke about the opportunities where customers can download their software, download features. That's only possible if we have the infrastructure of the cloud and the processes that can basically allow such an interaction to happen between the car and the cloud. So data backed with the compute capabilities of the cloud is going to be an important driver for AI. Now let me take you to the third section. I talked about how over the years since I first read the cartoon, there's been a lot of development. Customers have begun to understand AI, have begun to look at how we can monetize AI with data. And what you see on the slide are some of the areas in which MathWorks is sort of investing, right? So I just took this clip off our website. You can go there. There's a plethora of information on basically what are the areas that we are investing in, right? Now, as we have been working with customers who are using our tools, we also essentially understood how and why customers are using AI. And on this slide, I picked a few of them, and I'd like to take you through some of them. The first reason is to build innovative features. Automated driving would not have been possible without AI, because the perception piece of automated driving is completely AI, completely new to the automotive world. Not only are customers looking at how they can introduce new features, they're also going back to their conventional systems, their conventional powertrains, and looking at, hey, how can we improve existing products that are still running on the field? And I'll talk a little bit about that. Improve development workflows, right? How can I use AI to basically change the way, improve the way I'm developing my systems? With the data that is coming from the car, how can I interpret that data, right? How can I use that data? So that's another use case that basically the automotive world is looking at. And last but not the least, the automotive world, the very important part of the automotive world is the manufacturing, right? And the servicing of basically those cars. And AI has an enormous opportunity in those areas as well. So I thought about how I sort of bring these together, and what better way than to tell you stories, right? So I'm going to give you a few quick stories as to what customers around the world are doing, and hopefully for you as an AI audience, that can trigger some thinking about what can be the ways you can deploy AI in your organizations. So the first is just a quick check. Is this timer right? Do I just have 5 minutes? Oh, okay, so let's be quick about it. So the first use case is coming from Mahindra. Mahindra wanted a machine learning algorithm to essentially understand what kind of road their truck is driving on, right? So unfortunately, I can't go into the details, but I'm sure IESA will provide the slides. The link, the hyperlink here on each of these slides has a very detailed narration of the story by the engineers at these companies, right? So Mahindra built a machine learning algorithm to essentially decide what kind of road that truck is driving on. And from then, of course, they take decisions in their software to improve, let's say, their suspension, the driving feel, to improve the fuel economy, and so on. Now, for Caterpillar, essentially, they looked at building a big data framework where they can use their ground truth data to label it, to have a database of that where they can query it, to use it for validation, and so on and so forth, right? So that's the first piece about building new features. The second is about how to improve existing features. And here you basically have a classical team from BMW, a chassis team that's using AI to detect oversteering conditions. So that's one use case. The next story is coming from Vitesco, where they use reinforcement learning to build advanced controls to control the emission of NOx. The next is how do we basically improve development workflows? Now, both these companies, Stellantis and Renault, have used AI to build virtual sensors, and that's a big use case because they don't need to have that physical sensor. An algorithm basically decides how much NOx is there and what kind of strategies they need to have in their software. The next is around Volkswagen and Honda using their field data to decide, in the case of Honda, to decide basically their calibration for emissions, and in the case of Volkswagen, to decide how well a driver is driving the vehicle in their fleet of vehicles. And then, of course, they have insurance associated with that and so on and so forth. Right? And last but not the least, this is a story from Mercedes-Benz, where they basically use the sensor data along their manufacturing line to decide if there would be anomalies in their manufacturing line, and they can basically control the response to that before the actual breakdown of the assembly line. The last story coming from Baker Hughes, where they built digital twins of their pumps, and essentially they were able to, again, reduce the downtimes and predict failure. So it's a case of digital twins and predictive maintenance. So I spoke a lot about use cases. Sorry, I had to go fast. But this graphic tells us is, what it tells us is we're only getting started, right? We're talking about how we are using AI for processes, virtual engineering, but the true value of AI would be when we integrate that in vehicles, right? When we integrate that in the services very closely coupled with vehicles. And you can see from the graphic that the value of AI will actually go many-fold, right? Now to the audience here, probably the biggest opportunity lies with this industry, with the semiconductor industry. OEMs have traditionally worked, in a very hierarchical, we go to a tier one decides a semiconductor and so on and so forth. But with this transformation in software, new business models are emerging, right? OEM would maybe even like to work directly with semiconductor players or with tier 0 players or tier 0.5 players or engineering service providers. So this stage of transformation is actually creating new value chains. And that's when, in this disruption, there's a huge opportunity, and I would imagine a huge opportunity for the semiconductor players as well. I said a lot about the opportunities, people are using AI, and so on and so forth, but let's take a step back. There are also some, if I may say, challenges with AI, right? The first here, and the leaders on the first row will agree with me, is the skilling. To finding the right AI talent that really understand how to tie the domain of automotive along with the use case of AI so that you can unlock the value, so that you can monetize that. So that's the first challenge, skilling. And then, of course, we have other challenges like data quality. And all of us know in AI, bad data equal to bad AI, right? In both these cases, and I don't want to go into a marketing pitch here, but in both these cases, MathWorks is a company that provides the tooling that can help engineers, that can help business leaders to train their teams, to have domain teams to start working with AI. And basically, the main philosophy that we have is AI is never just about the algorithm, especially in automotive, right? AI has to start from you working with data and then basically developing the algorithm and testing that algorithm in the context of a domain. If it is automated driving, you have to put perception in the automated driving stack, right? If it is a powertrain use case, you have to put it with several other components of powertrain. And that's when you can really unlock and understand AI in your domain. And last but not the least, you have to deploy that AI. That can be on the embedded device, like you saw on the BMW use case. It can be on the cloud. It can be on a cluster. Essentially, you need tools that can help you to deploy the AI. I can't change. Just have 2 more slides. Okay, thank you. And when I'm speaking about opportunities, Balpreet told me you have to talk about generative AI, right? How can you not talk about generative AI? So I'd also like to touch upon it for 30 seconds. As MathWorks, we are exploring large language models. We are looking at how our tools can basically work with generative AI. I think all of you by now in this conference have heard about large language models, so I'll skip this slide. But essentially, as MathWorks, what we see is that these are some of the use cases where we can combine our tooling with generative AI, right? So more about that. You can watch out for the MathWorks releases, which will basically now combine generative AI with our tooling. So this is a small example of command prompt where basically you can have a voice prompt and our tool can generate MATLAB code for you, right? Moving on very quickly, and I think that's all the time I had. I started with this, I started with skepticism, but I want to end on a very affirmative note, right? I'm reading literature that says, adopt or phase out, use AI or lose out. And I'm very positive that these messages are true because the kind of value multiplication that software and AI can bring is enormous. So I think we as a community, as an automotive community, really need to collaborate, right? Right from the semiconductors to the tier ones, right up to the OEMs. And I also want to pitch in that MathWorks as a tool provider can basically work with all of you. We work with all these customer segments, with all these domains, and provide the right tooling. And we can help you to train your teams. We can give you the right tooling to write your algorithms, to test your algorithms, to deploy your algorithms. So that's all I had. Thank you very much for your patient listening. But before I leave you, this is a QR code for something we call as the AI chat playground from MathWorks. You can scan this QR code, try out a few generative AI examples, if you're interested. Thank you very much. I wish you a great day of learning ahead, and let's AI together. Thank you.
Thank you so much for the insightful talk, Rashmi. Actually, you gave a lot of insightful thoughts like data, cloud, and so many other things like sensors and how OEMs are feeding back the data to semiconductor companies. It's really wonderful. Thanks a lot. Now, may I request Mr. Balpreet to felicitate Ms. Rashmi Gopal Rao. Can we have a huge round of applause?
Thank you, Balpreet. Thank you.
We have an interesting panel discussion coming up on navigating new road ahead, the automotive industry's AI-enabled future. Our moderator for this panel discussion is Mr. Srinivas Raju. He is conference chair of IESA, and also he is the CEO of PySquare. PySquare Technologies is a state-of-the-art automotive embedded software engineering and consulting company. I would also Mr. Krishnaswamy Jambunathan, Vice President and Head Tech Center India, Generative. Mr. Bhimsen Joshi, Head of the Department for Software Development, Hyundai Motors Engineering. Mr. Rahul Rajapalepu, Vice President and Head of India Hub, Stellantis ICT India. Mr. Srinivas Pardasarthi, Senior Manager, Automotive Sales, Infineon Technologies India Private Limited. Now I hand over the stage to our moderator, Mr. Srinivas Raju. Thank you.
Morning. I know I actually wanted to start with, because we see a lot of semicon folks here, mostly on the chip design, embedded software solutions. I wanted to set the context. I think Rashmi has done my job. I think she's already given the necessary input. First before I start, I would like to introduce our esteemed panel. I don't think we can put together any better panel than this. I think we have some of the best people in the industry are here with us in our panel. We have Mr. Krish Jambunathan. We call him Krish. He's the Vice President and Tech Center Head, ZF Group. He's also Executive Director and Board Member of ZF India Private Limited. Just to give you ZF is one of the leading automotive tier 1 companies with about close to 43 billion euros of revenue and 165,000 employees globally. Krish comes with over 33 years of experience and he has led growth of GCCs in India and primarily helping global companies to set up in India. And of course, and he also built engineering competencies of automotive domains, product development, and he's currently the ZF Tech Center India head, and he leads a team of over 3,500 engineers and the largest software center of ZF globally. Krish graduated from NIT Calicut and worked in other automotive GCCs before moving into Hyderabad. I mean, he was earlier with Visteon, Delphi, and thank you, Krish, thanks for making it. Yeah. And we have Mr. Rahul with us. Rahul is the Vice President and Head of India Digital Hub of Stellantis ICT India. Rahul has been spearheading the ICT division of Stellantis India as a Vice President and Head of India Digital Hub for over 18 months now, and he's been appointed as the director of the company effective December 2022. And he's also an accomplished professional with about 30 plus years of experience in IT industry. Again, you know, he brings the IT, AI, the digital transformation side of it. And he's also accountable for managing technology teams and support functions of global Stellantis IT and digital teams and local support functions for their global digital hub. He was also, earlier with global majors like GM, auto majors like GM. His current role involves overall center growth strategy, digital transformation initiatives. Thank you, Rahul. Thanks for making it. And then we have with us Mr. Bhimsen. Bhimsen Joshi is software development leader with over 21 years of experience in the automotive industry, including working for world's third largest auto manufacturer. Track record of setting up, scaling, and leading multidiscipline software development teams for business critical domains like chassis, body, and autonomous driving. And of course, delivering cutting edge technology breakthroughs by leading diverse teams across multiple geographies. He's passionate about new technology, and he's done his master's from BITS in data science and engineering, and also, of course, his graduation from Osmania University in electronics and communication. Thanks, Bhimsen. Thanks for coming. And we have another esteemed speaker, Mr. Srinivasan, and he's the senior manager focused on automotive sales in Infineon. Srinivasan is handling some of the key global and local tier 1 automotive suppliers. He comes with over 22 years of global experience in semiconductor and distribution industries. He played a key leadership roles in developing an account with good working relationship at all level in the complete product lifecycle design with auto companies. Prior to Infineon, he was working for leading semiconductor manufacturers like Cypress, Micron, ST Microelectronics, and also led their distribution initiatives with Nexcom and Excel Point Systems. Thanks, Srinivasan. Thanks for coming. I think we have an excellent panel. I think over the next 40-45 minutes, we will deep dive into some of the very important topics in automotive and listen from the leaders in the space and their views. And I think I will try and keep at least a couple of minutes for audience questions, which is important, and then I think we'll conclude it. Thank you once again. Yeah, I think what I will do, I'll start with, I'll take a couple of minutes initially to start with, okay. Can we have the slides, please? Yeah. So AI being horizontal, by the time slides comes up, I think AI being horizontal, I think we have seen every industry, be it healthcare, automotive, financials, I think BFSI, every sector, I think obviously, in some form or the other, they're adopting their AI journeys. And I think automotive is at the edge of, I think, implementing, AI across all their subsystems, right? I mean, not just autonomous driving. So what we will look at is, I think, basically, just to set the context, I think you look at vehicle. I think you see car, it is 1886 is when, I think, the gasoline engine powered cart is introduced. And then 1960s is when the Bosch has introduced their engine control unit, the electronic, the semiconductors started getting into cars. I think that's the journey. I think over 130, 140 years of automotive history, I think everything is revolutionizing, transforming, and a lot of things is going to change in the next 10 years, right? And what is driving that, okay? So in terms of evolution, if you basically see, so first is basically everything tied, your legs, hands, eyes, everything is tied to a steering, clutch, brake, everything is, and your eyes on the road. And then there is some level of autonomy came in the next gen of vehicles. I think that is where you have a little bit of your hands free because you have, auto gates coming in, or, finger controls have come in, and you have adaptive cruise control systems have come in, right? I mean, it eased out a little bit. And the current generation future is basically we are talking about ADAS and autonomous vehicles. I think that is where you can keep your eyes off, your hands off, I think as if you are sitting and having a meeting with, any hotel or restaurant, right? You can just move point A to point B. The mobility is going to be, the future of mobility is going to be that. Okay. So I think in the interest of audience, I think ADAS levels that we talk about is basically, I think we all say level 1, level 2, level 3, level 4 kind of levels that we've discussed are level 5, right? Depends on the level of autonomy that we're talking about. These are levels. And predominantly we are in that level 2 plus kind of a journey with most of the automotive vehicles. And I think another thing which I would like to set it up here is basically, I think the code, I think we all talk about software in cars. Just to give you a comparison, I think a Boeing aircraft has close to about 4 to 8 million lines of code, but the current gen cars has anything between 30 to 100 million lines of software code getting into it. And people are saying the future autonomous vehicles will have close to about 300 million lines of code getting into cars. They're more complex in terms of software subsystems are concerned, right? The whole platforms are changing. Okay. So, yeah, I will set the context for our panel discussion. I think some of the trends that we have discussed, and those trends are basically, I think, AD, autonomous driving and ADAS. And then the software platforms, right? Almost all OEMs and all tier ones, all automotive companies are trying to, OEMs at least building their new generation software platforms. There, and the impact of AI across, right? I mean, again, the digital cockpit, the user experience, the personalized user experiences, and then we are talking about connected vehicles, and of course, smart and sustainable manufacturing, right? Just-in-time manufacturing. You can configure your car as you require, and then customize it, and you get it. You can track right from when you order it till your vehicle comes, like your Amazon delivery, right? And then, of course, the regulatory framework. Who's accountable if there's an accident? Is it the autonomous vehicle or the car manufacturer or the person who bought the car? I think these are aspects. So we may not be able to touch upon all the points in the interest of time. I think we'll pick up some 4 or 5 questions and then take their views. I think otherwise the panel is available, speakers are available off the dais, and then you can have discussions with them subsequently. Yeah. So without taking much time, I think I'll probably start with, I think the buzzword is autonomous vehicles, right? We all talk about driverless cars and autonomous vehicles. Everybody are investing big into it, the Googles of the world, Amazons of the world, of course, Teslas of the world, and almost all the OEM majors are now getting into that space, right? So one of the things, AI is basically, propelling autonomous vehicles from science fiction to everyday life. Whatever we have seen, those science fiction movies are becoming reality now. In that context, basically we want to have views of all of you on how AI is currently being integrated into automotive industry and what are the most significant developments we have seen so far, right? I think what is reality, what is hype, I think probably, some inputs from you to the audience would help. Please, sir. I think we can start with you. Yeah.
Thank you, Srinivas, and thanks again for the panel. I think we have also our customers online here. It's, I think when you talk about, I'll give 3 words that we see as a concept, which is see, think, and act. And that's what defines for us what is mobility about, and we call it as next generation mobility. Rashmi touched upon the C part, which is basically the perception, the camera, and how we are able to perceive objects, and that becomes very important. The second aspect, think, is very relevant also to this audience because we are talking about today about computing power. When we talk about how the semiconductor change has really led to this, because we have our own platform called as Pro AI, and that is basically a supercomputer in the car. And this becomes essential because of the data that we are to churn and the decision making, which means in real time. So talking about technology, how the see, think, and act translates to is one of the developments that we can talk about is on the mobility space. One, on the micro-mobility, which is again talking about sustainability and e-mobility that is coming in. But on the other end of the spectrum is what we talk about mass mobility, which is shuttle. So ZF is something that has piloted the shuttle in a big way, and the basis for that whole shuttle is our ability to have a Pro AI platform. And that is what translates how AI has been able to possibly bring in this hardware change that leads us to have a product like a shuttle. And that is a people carrier, and which is already in trial. And this is where we really see all the systems coming together, that the computing cover in real time, and also we'll talk about connectivity as we go through, so that I give time to other colleagues also, where we have a 5G connectivity and other development. So with that, that's one key area where you can really see the autonomous vehicle taking shape on a public carrier.
Thank you. Probably your view.
Yeah, hi. Hi, good morning all, and thank you very much for inviting me here. So, first of all, I'm so thankful that I'm born in this era, and we are all seeing a tremendous, phenomenal change in this technological revolution that we are in. So, and we are not only seeing it, so being a part of industry, together we are all making this particular change. So, and it is so exciting. AI happens to be one of the technology that has come up that we are integrating in automotive. So what has struck me, so just with my experience I'm seeing is the voice recognition part of it. So now, even though it might sound so simple for a user, so you talk to a computer or some mic inside some mic and some things happen. There's a lot of technology which is going behind it. So what you speak is first of all a voice or a sound which goes in, and then that converts into electricity. That electrical signals that are converted has to be interpreted, and then that has to be processed. And then it has to be processed in different languages. So you can imagine the amount of technology that is there, the natural language processing that we have come up with. So what has this enabled us overall is in automotive, now you can give voice commands. And through these voice commands, you can actually control the entire car. So the perception that is coming up now, especially in some parts of China and other countries, is that in this electrical vehicles, so if there is an electrical vehicle, so the thought process is that it should not have any buttons. Okay, nowadays what we see is in our cars in India, we see that there are so many buttons here and there to control, so to roll up the window, to turn on the AC and something like that. So, but the trend that is coming up is no buttons at all. So, if it is a futuristic EV kind of a vehicle, you don't see buttons. So, what do you have? You have voice commands. So, you speak anything, you have a personal assistant installed in the car, and that talks back to you in your language, and it takes care of all the controls that you want to do. So, not only car controls, but also outside connectivity and all. Of course, you have displays. So displays are all 3D graphics and all. So you can use those graphical controls to actually control the airflow. So suppose you want to make the airflow down. So you just swipe it down and then the airflow starts up. So now this is a remarkable feat of achievement which is now already in production and people are using it. So AI is really transforming the automotive sector, and much more exciting things are about to come, and we are about to see and have a very good time is what my opinion.
Thank you. Yeah. Sir, Mr. Rahul.
Thank you. Again, Rahul here from Stellantis. Thank you for this opportunity and good morning, everyone. So I just want to cover a little bit from an OEM perspective, right? I mean, so AI in automotive industry is used across various life cycles. I mean, so for example, if you take from a concept to getting to SOP, start of production, how many of you know how many weeks it will take? Any guesses for a car? It's about 125 to 135 weeks. So it's little more than 2 years. And so from a concept to start of production. So that's the life cycle we are talking about. So how is AI helping in all this, right? So if you talk about a design phase, today there are tools and techniques that are available using AI where you can give a voice command thanks to generative AI. It can generate the design for you. Earlier people used to do prototyping and then clay modeling and all this stuff. So today you are getting an image which is maybe 50% ready, but it is reducing that much time in your design life cycle. I mean, so that's the advantage that you are getting. So you can predominantly reduce the whole life cycle. That means you can, the time to market is coming down by that much. I mean, so this is across OEMs. I'm not talking about Stellantis alone. So similarly, you take production. So predictive maintenance, I mean, so you have also touched upon that. I mean, so a lot of sensors. You have so many IoT devices that are going in, so much of robotics inside your plants, getting and generating so much of data. You are able to predict when a particular equipment would fail. I mean, so that is basically reducing your cycle time. I mean, so basically your downtime rather. I mean, so from a production point of view. BMW actually implemented this very effectively, I mean, so in their plants. Similarly, the design concept that I've said, Toyota Labs, so they have implemented this design concepts. So similarly, supply chain. Supply chain today is the biggest issue across the globe. So we have a lot of supply chain issues. So getting the material right in time for an OEM manufacturer is a challenge. How is AI helping? I mean, so AI is basically helping you to track your vehicles, where they are, when they would expect, and what is the optimal route. So everything you can do from an AI perspective. So today the entire supply chain, using AI, you can optimize big time. So like this, in every phase, you can go on and on. I mean, so I'll come to autonomous in a bit. I mean, so the biggest use case everybody talks about when you talk about AI is autonomous driving. So yes, I mean, so obviously that is the biggest use case that we have. But today, we are still at level 2. I mean, so you have shown the 5 levels. Most of the majors today are at level 2. I mean, so nobody has really, some people claim that they have come to level 3, but not yet. I mean, so we are still at level 2. There is a long way to go from an AI perspective. So I'll also give some examples later on if given a chance. So we will see how autonomous driving and AI are helping for the next gen mobility. I mean, so we will probably talk about in a bit. I mean, so that's my perspective.
Yeah. Thank you. Thank you, Mr. Rahul. I think we'll
Good morning. Thanks to everyone. Thanks, Srinivas. Thanks, Rahul. And to be very, this one, all the 3 are our customers. They are one of our key customers. Okay. So how semiconductor is important in each and every domain, this gives a very important. Okay, see today the most important thing in car especially or in an automotive, what you see, you pay for it. You take an example of Mahindra XUV 500 versus 700. The major difference apart from the engine or the user experience and also the features in terms of safety ADAS, these comes only because of the semiconductor. And though we do high performance computing, those are on the cloud side. But at the edge side, which is most important, which is safety critical and also redundancy. So ADAS is possible only level 2 or level and other levels is possible if you have a electronic power steering, not the hydraulic power steering. So semiconductor plays a very, very vital role, like Mr. Rahul mentioned, even also on the supply chain part of it, building the roadmap together. And if you see the overall architecture, like Reshmi mentioned, right, the market is, or the architecture is moving from zonal architecture, domain architecture to zonal architecture. So more and more optimization is going to take care, and also collecting more number of data so that we also partition the vehicle in a proper way, which is mission critical, which is also safety critical. So those are the parameters also can be monitored very closely, and optimization is very much possible. Yeah, so semiconductor is a very, very important for all the computing power, everything. The sensors are most important. So if you have the right data, then only you can do the right computing also. Yes, that's for my side. Yeah.
Thank you. And I think probably we can start our questions after listening to their views. I think common we all hear is, I think AI is, pervasive, especially when it comes to building perception algorithms, when it comes to either ADAS level 2 plus is where I think most of the automakers. I think we should be, proud that our Indian OEMs are rolling out cars in ADAS L2 plus, right? The Mahindra to, your Tatas to, everybody are coming in L2 plus segment. So I think ADAS is advanced driver assist systems. I think that's the stage where it's a supportive system to a driver to, basically improve safety. And I think that's the phase I think most of the automotive companies are moving in right now. So one question is, what are the potential safety improvements, challenges associated with integrating ADAS with AI-driven technologies? I think probably, we will have, views of Krish on this. Yeah.
Yeah, I think what comes up, as we said, is I think I go back to what Rashmi is also saying. It is not always that the data that is coming back is correct, but the most important is in the whole ecosystem we talk about dealing with a lot of data, and when you deal with this sort of data, how are we able to get a pattern out? We again talk about Gen AI, but again the point here is we are able to get a pattern out to make the decision making. We talk about two paths usually, the safety path and the performance path. And that is one thing that we try to do, which is probably inherited to some extent, I would say, from how we do in an aero system or anything, is to make sure that we do not have a chance where there's an error. Because obviously, safety becomes very critical. That's why we have the standards on that. But the idea is, how do you bring in the system so that you have a redundancy built in, so that we can make sure the decision that is made is correct. But at the same time, we are forced to deal with a lot of data in real time that requires us to take decision quickly. So definitely AI helps in that part, but equally, how does a robust system, because automotive is one thing that's always known as a very robust system, which probably when you talk about a computer, we do not expect that to have an issue, we still can live with it, but not in an automotive system. And that's where the robustness is inherently built in the way we build systems, and that we use it in combination with AI so that we can bring out the best of both worlds. That's what I would say. Sorry.
Yeah, I think as a follow to this, I think we all talked about typical automotive software development, V-cycle. Earlier it used to take to freeze requirements about a year or two and then start the development. Now we are saying the features are, typically like your IT agile methodology, right? So how do we ensure, especially on the code, software code front, meeting all the compliances, standards, the test processes on the development side? Maybe Mr. Rahul, I think since you're driving that agile practice.
See, today, so as you were also mentioning, right? So the experience of what people want, so what we call as customer experience, is changing. So it's not like earlier days where you go to a dealership and then you look at a car and then you decide what you want to do. So today, most of the information for you is available even before you actually visit the dealership. By the time you go to the dealership, you know what exactly you want. So in that context, getting the right features into the car at the right time or to the level of customization the customer wants is becoming much more critical. I mean, so that's where we are talking about. I mean, so even Rashmi touched upon how we moved away from the V-cycle into the agile ways of working, right? So this is where the concept to implementation in an agile fashion and getting it so quickly into the car with the testings and with everything that you need to do is becoming so much important. I mean, so how is AI helping? I mean, so there are so many tools. Today, even for your information, you can generate your use cases using GenAI. And so you can basically talk about, okay, this is the feature that I'm looking at, and then how do I generate my use cases or the agile ways of working use cases, testing, and what kind of people that you need to deploy. I mean, so am I having the right team? Based on the lot of data, AI is helping in terms of making that decision for us. In terms of, yes, you have 2 Java developers, but the feature that you are going to introduce tomorrow requires you to have a MATLAB developer. So you can still have that level of information coming from your AI system. So that is how the agile ways of working as well as AI is helping in terms of getting the features into the car. So.
Thank you. I think as a follow-up to it, I think...
Mr. Srinivas,
I think
sorry,
please, I'm sorry, please.
Yeah, so it is a very interesting thing that came up just in my mind. So you talked about the safety part of AI integrated into automotive. So I will slightly go in a counter positive, in a kind of a cautious thing. So AI, as we know, the field is emerging and there are different techniques of AI. So you have some techniques which deal with algorithm. So you have search algorithms like breadth first search and other things. So these are all, some of them are definitive, means when you do the prediction, it's almost like a correct kind of a thing. And then you have, you move into a territory of ML and DLs and machine learning, deep learning and all. So when you talk about this deep learning, so these are layers of neurons and all. So to simplify that part, so suppose you have an equation y is equal to mx plus c. So that's a very simple equation and a single dimension kind of a thing. So you just have to find out what is m and what is c. But our systems are very complex. So when you go for a DL, which is a very complex system, though this equation really explodes and it has got numerous or millions of parameters, which no human being can understand actually. So when you are training this system for a very complex system like autonomous driving or in terms of perception systems or to identify a particular image or a particular scenario, so when you train this model, what eventually happens is this complex equation with millions of parameters, we get a value for each of these parameters. And then as a human, nobody can validate this kind of a thing. Only thing that you can do is you can do a lot of testing and feel secure about it. Okay. So, but this surprisingly has worked for many a times and we are seeing some good output right now. But to get into a real safety critical thing, I would be a little bit more cautious and do more sort of testing. But as he rightly said, we will have to build up redundancy systems and ensure that we really don't fail. So AI, even though it sounds so exciting, human beings don't understand exactly what is the equation and all. So just my thoughts on that.
I think probably tell what computer were writing billions of lines of code. We've been driving vehicles without all that. Now you can understand the human brain complexity. I think in the interest of time, I have a couple of more questions which I want to really cover. One is, we all talked about the new new automotive architectures, right? I mean, like Srinivasan has touched upon. Earlier we had domain-based architecture where we had ECUs for almost every subsystem in the car. Like you have body controls, engine controls, powertrain, infotainment. For everything, there's an ECU. Now that has changed to now, zonal architecture or CCU and zonal structure. So there comes the need for high performance compute. The overall, earlier that 30, 40 subsystems, we had a CAN network and they're all communicating. And now we are saying everything is, heavy lifting is done by a HPC, right? So what is the HPC, what is high performance compute in the context of automotive, and why is it gaining prominence? Right? I mean, probably Beam and Srinivasan can.
So, like you said, see, when we move to the zonal architecture with electric electronics, right? You can see certain things. Today, if you compare the ICE vehicle versus the electric vehicle, let it be a two-wheeler or even a four-wheeler, the weight, the mass of the vehicle is not changing much. But if you move to the zonal architecture, one is you are going to compute each and every region, and the harness of the vehicle is also drastically coming down. So the weight of the vehicle is coming, which is nothing but you are going to get more mileage out of either the charge or even the gallon. And the other thing, the major advantage what we are seeing is that, so like I said previously also, what are the critical nodes? So even in a car, there will be a central computing device, but it not necessarily need to always talk to the cloud, because it will also capturing data, and based on that, it can take its own decision at the edge side itself, rather than going every time to cloud and computing it. So more and more on the architectural change, which is really creating a lot of values. And other things, like for example, one of the two-wheeler, electric two-wheeler in India also, right? So he designed a vehicle with which can take up to say 200 ampere. Later, after say 3-4 years, he had the complete data around India. He realized that I think 120 ampere is more than enough. So based on that, he also decided how optimization is also possible. So there are multiple ways that you can look into it, how we are going to use the data and the high performance computing also. Yeah.
Okay. Yep. So when I look at it from a OEM perspective, so what are the things which are driving us to move towards high performance computing? And I'll also briefly touch upon what is this high performance computing in terms of automotive. So there are two major factors which I see. One is the feature demand. So you have new features which are coming up, so autonomous driving, which we all spoke about. So this kind of features to implement in a traditional ECU is almost impossible. Why? Because a huge amount of data that comes in, you have to process that data. First of all, you have to store that data, you have to process that data. So that is not possible in typical microcontrollers with single core or two core kind of a thing. You need high computing. High computing means what? You need more number of cores. So you need like more than 200, 300 cores. You need different types of processing units. Like CPU is something which is like a general kind of a thing, wherein you have a OS which controls everything. But then apart from that, you need GPUs, you need NPUs. The new thing that is coming up is neural processing units, which are a specific class to help the deep learning and all those things. So one is this feature. Second thing that is driving this HPC is SDV initiatives that is coming up. That is consolidation of all the ECUs. So you take all the features from various parts and you consolidate. So that is not possible through the microcontroller. So you need a HPC, wherein you have a high bandwidth transfer, and then you have so many applications running on this HPC. So these are the two things which are driving this HPC. So what is this HPC? I was touching upon it. So this HPC is something which is having more computing power, more variety of computing power, CPUs, NPUs, GPUs. It has got more RAM. So traditionally we were having some KBs of RAM or something like that in microprocessor, which was ECUs are designed to do specific tasks. But HPCs are like generic kind of a thing. So you have GBs of RAM in that. So these are the things which are required for HPC.
Nice. I think I had one more follow-up, but I will touch upon that point. And in the interest of time, I'll move to next question, which I wanted to ask Rahul, especially on the connectivity side. I know we all talked about one is user experience connectivity. What are the typical 4-5 use cases that you see for connectivity, and then especially data privacy, right? The moment car is connected, security and privacy, I think these two issues will come, becomes important. Yeah.
Sure. I think Bhimsen also covered, and Srini also covered. I mean, so if you look at from HPC side, as we are saying, so one is the computing power.
Yeah.
The second element that you're talking about there is also the network. So today, the edge which is sitting on your vehicle need to communicate with cloud at some point in time. I mean, so that's the only way that you can achieve the results that you anticipate, because 5G becomes very, very important in this whole equation. I mean, so especially when you're talking about updates over there, and so which is very, very important in this context. Sometimes you're talking about your navigation systems. So real time, you need to get the update when you're actually going on a highway. I mean, so something happens somewhere. So you need to know what is the deviation that you need to take. This is a real time update.
Right.
How do you get it? I mean, so the network has to be there.
Right. Right.
So the connectivity at the speed that you need at the split second, I don't think 4G can provide. I mean, so this is the current issue that most of the OEMs are facing. I mean, so
Right.
we need the 5G connectivity. I mean, so from a network infrastructure point
Right.
of view.
Right.
The second is the security aspect, which you also touched upon. It is very, very critical. I mean, so imagine we achieve 100% autonomous level 5 autonomy, and then your car gets hacked by a hacker, which is possible. I mean, so if over-the-air updates are possible, so hacking is also equally possible. So the car is controlled by somebody else. So this is the biggest issue that people see. The second is there is so much of personal data that is getting stored. I mean, so whether you like it or not, today you go to a car, I mean, so there are some features that people are talking about where you would also have a face recognition camera inside the car, which will actually tell you, okay, Rahul is getting into his car, his seat need to be at 15 degrees from this side and then 15 degrees from back side, automatically adjusting. I mean, so we also have that feature in some of the Indian cars as well. I mean, so like this, there are so many personalized features that are getting into the car. That means when your personal data is also there. So your driving patterns are there. This is actually the issue if that gets into a wrong hands. I mean, so there are a lot of negative data. Personalization also has its own perils. I mean, so just on a lighter note, I'll give you one example. It's a joke, I mean, so don't take it serious. So let's assume that, okay, you are in a car where it's telling you, you are going every day to your office. On the way, you pick up a coffee, and then you stop at some place for half an hour, and then you go to office. Every day, the guy is doing the same thing. So one day, this guy, instead of Starbucks, he stops at Dunkin' Donuts, and then the car says, you usually stop at Starbucks, why are you stopping at Dunkin' Donuts? I mean, so you get irritated or not? I mean, so this is one use case. So I said, oh, he's also stopping for half an hour at some place and going. So one day, he's going with his family. And then suddenly it says, okay, so you are supposed to stop for half an hour at this house. I mean, so why are you not stopping? So, and the wife divorced him. So this is the perils of personalization as well. I mean, so just on the lighter side. I mean, so.
No, very interesting. I think these are practical issues. I think this you have to overcome. Yeah. Your views, Krish, on this?
As I said, the personalization is very important, because what also happens is we are all so much used to it. You just open anybody's Outlook. Do they all look the same way? No. It's all same Microsoft Outlook that people have. Look at our mobiles. We all have the same mobile, but do we have the same Outlook? No. So that is a natural expectation now. One of the mega trends globally is user experience. And that user experience now goes into whatever we use on, which is again also the automotive that also Rahul explained in terms of detail of what going through. And that's where what happens is with the data that we have, are we able to create a pattern? Yeah, maybe it creates a funny scenario also, but that personalization becomes very important, because people want, one is we talk about connectivity from a 5G or anything, but people also want to be connected to the vehicle. For example, seamlessly, when I come in, I am listening to a song, I do not want that to get interrupted when I get in. So the same song plays, and that's what happens. The map that you see today, what has happened is, if you see on the connectivity, we really brought in this connectivity of the mobile phone to the car infotainment system, because in the past we used to have the maps in the car. We don't use those maps anymore. Whatever maps you have on the mobile is what you want to see on the screen. And that's one of the very strong examples of personalization where the user experience is driving what the car or the developer has to provide. Just to give an example.
Thank you. I think one last question, and before we conclude, is basically on regulatory and the ethical challenges, right? I mean, this is, I think, predominantly discussed at global level, a lot of forums. I think they'll have to come up with some policy to ensure safety, not just the people in the car, even the pedestrians. And then how do we ensure? Maybe one view from each one of you to conclude it. Yeah,
I'll go first.
Yeah, please go ahead. Yeah.
It's again a long debated topic. I mean, so we all know this. You take United States alone. So the 50 states have 50 different laws from an autonomy point of view, right? So getting all of them onto the same page and then having a standard regulation, it's going to take time. I mean, so today I don't think we are there. I mean, so honestly. And even to test the vehicles, so there are different rules at different states. So, and the level 2, what somebody claims in a European country may not be level 2 in some other country. I mean, so that is how different the regulations are today. So standardization across is one definite aspect that's required. We also talked about the communication. And so the vehicle today need to communicate with vehicle to vehicle, V2V, and vehicle to infra.
V2X.
Yeah, and so it also need to understand what is coming from the surroundings. I mean, so is there a protocol that is standardized for these kind of things? I don't think so. I mean, so today it's everybody's wish and fancies. I mean, so in that context, again, the infrastructure, I mean, so forget about even the communication infrastructure, even the road infrastructure. For example, I mean, so I'll take 1 minute extra.
Yeah.
So recently I was driving our Jeep, the Grand Cherokee, I mean, so on our ORR. So for all of you who know, ORR from 100 kilometers per hour, it has moved to 120 kilometers per hour. I mean, so you can drive at that speed. Whereas if you see the signboards on the side, they still will say 80 or 100. So because they are not changed. And this car actually goes with the signboards. I mean, so it is actually reading that. And I'm going at 120, it is reading 100. And then it starts beeping, saying, you are going, it won't stop because I mean, it is reading from the infra. So it's not only that we are changing the infra on the car or in the surroundings. I mean, so everything need to change. I mean, so lane assist, for example, I mean, so you talked about ADAS. If the lane marking is not there, it would assume the extreme ends as the lanes. Because it's, I mean, that's the intelligence that it has. I mean, so these are all the things. I mean, so I think unless these change, I don't think we would see the real implementation of AI or autonomous driving in countries. That's my
Thanks, Rahul. I think Krish, you can go, please.
Okay. See, regulation plays a very, very important role, not only for the user and also even for the OEM. See, I'll give you an example. When BMW first wanted to come to India, right? So they had a lot of debate with the government that without a spare wheel, you cannot register a vehicle. But today, if you see, if you have a TPMS along with the puncture kit, then you no need a stepney to register a vehicle, the spare wheel, right? So this, if you see, because of nitrogen and other things, right, the tire burst is very limited, or I would say no tire burst. So this not only creates value for the user, and also it's a good for the safety, and also from an OEM perspective, it also saves money on the things. Okay, so yes, these are very important. I think the currently we see a lot of regulations, like in a two-wheeler, there were a lot of side stand, there were no indicators, rollover sensors. So government is also now trying to implement a lot of sensors and also the regulatory into the thing, which is very important. Yeah, that is most important also. Yes.
Sir?
Not more than 30 seconds. So the last point is on the regulatory. While it is very critical, AI also gives a solution, which is something called as what we call as digital validation. So what we try to do is, how can we bring down the amount of time that we spend on testing or validation upfront in making physical products. So that is something, again, we are as a tier one, but working with the OEMs, the concept is evolving where you can create digitally, validate the product without actually having to build it. What does that get? It helps you to validate all the possible use cases without physically having to go through that. And it also saves time, one. At the same time, helps you to meet, while the regulations are something that we cannot define, what is being defined, you are able to go through all that because of this development. And that's where AI also helps in improving how we can meet some of the standards and regulations that come in. That's one thing just wanted to share on that.
Me?
Yeah. Hi. So AI mostly depends on the data nowadays. So we collect huge amount of data, and while collecting the data, there are so many challenges. Okay. So you get the name of the person. So should I use the name? Okay. Maybe it is not required. Then we get the age. So should I use the age? Will it be a problem? I get the gender, and then I get the review comments and the ratings or something like that. If I have to analyze all of these things, what can I use and what I cannot use is a big kind of a challenge. So there is currently more regulations, I think, have to come out in India as a whole. But then ethics is also one of the things that you added upon.
Yeah.
So similar challenges we were faced while we were doing the project. And then we have to think about what is right and what is wrong. So it is on an individual basis, right? What you think as an ethically, okay, we are not going to use this data in a wrong way to harm anyone or to get a personal advantage kind of a thing. So then ethics is, again, it is up to organization or an individual level. Regulations have to come as a whole.
From the common point of view.
Okay, thank you.
Good. I mean, I would like to conclude. I know I have a couple of more questions as we discussed, but I think I will conclude it here. I think, first of all, thank you all for taking time and sharing your views. I mean, for me, it's been an excellent session, and I'm sure all the delegates probably got the required inputs. To conclude, a couple of things. I think the future car is all about safety, secure, and then user experience. So you want cars to be more safer, more secure, more user experience. So your AI, the new technologies that are coming is primarily to achieve these couple of things. And then, of course, government is in a very initial stages of framing some regulatories to bring in accountability in case of car accidents, especially in autonomous vehicles and these technology related. So thank you once again, and hope you all liked it. I think a big round of applause to.
Thank you.
Thank you very much. That's a very, very interesting discussion. Now I request Mr. Srinivas Raju to felicitate our panelists. Interesting discussion.
I think you all can also join him. Yeah. Join. I think you all can join. No, all can. I think we all can be a part of this. Thank you, sir. Thank you. Beam Singh. Thank you. Rahul, thank you. Thank you.
May I request Mr. Sanjay C, Corporate VP AMD, to come out to the dais to felicitate Mr. Srinivas Raju.
We will take one group picture. Sir.
Can we have a round of applause,
Thank
please?
you. Yes, sir. Join. We'll take a picture. Please.
What's your reflection?
Next we have a keynote address, Generative AI, Emerging Trends and Future Directions, We will hear from Dr. Jai Ganesh, Chief Product Officer, Vice President and GM, Harman Digital Transformation Solutions. He is an award-winning digital transformation and innovation leader with expertise in leading technology strategy, organizational innovation, research and development, new product and services innovation. Recognized in the industry as an innovator with a proven track record of converting new technology ideas into successful business opportunities. Built several global award-winning products, several solutions across areas such as social network analysis, generative AI, predictive analytics, quantum computing, machine learning, deep learning, natural language processing, web accessibility and usability, and augmented reality. Prolific inventor with 16 granted patents and dozens of awards from renowned organizations. He holds a PhD from Indian Institute of Management, Bangalore, and an MBA, recipient of Chevening Rolls-Royce Science and Innovation Fellowship at the University of Oxford. Please welcome Dr. Jai Ganesh.
Good morning. Am I audible? Is it? Okay, good morning, everyone. Welcome to this session. Thanks for the kind introduction. Let me start this session by giving you a very, very interesting example which I went through recently. I am from Bangalore, and in Bangalore we have this interesting concept of peak Bangalore moments, right? So peak Bangalore moments are incidents which are very, very unique to Bangalore. You must have all seen the WhatsApp message recently where people stuck in a traffic ordered Domino's pizza and got delivered and had this during traffic, right? So that's one example of a peak Bangalore moment. So I had one such moment about 2 months back. I was coming in early morning from an overseas trip, and I was going home with this cab. And as I started chatting with this cab driver in terms of what are the how his life is, etc. So, one interesting thing about you find in many of the cab drivers in Bangalore are they're extremely technology savvy, right? So they're very, very quick to engage into a discussion about technology. And obviously we ended up talking about AI, etc. So, and an interesting thing which came up around, all the developments around AI, autonomous cars, etc. I told him that recently I went through, I was in an SFO and I went through the cruise, and it was a wonderful experience. The car drove itself, etc. And then I started prodding him, right? He's a car driver. Autonomous cars are going to come in. It's going to be a disruption for jobs, etc. So I asked him, are you not worried? He said, if something happens like comes to India, I was expecting an answer that these cars will never drive in India roads, right? So, I was thinking that's the obvious answer which I get from him. But what he told me was very interesting. He said, if such cars come to India, I will take an early retirement, buy a few of these cars and make it drive for myself, right? That's one example of a peak Bangalore moment. With that, I like to set the context in terms of the content I'm planning to share. So can I get a quick show of hands as to how many of you are dabbling with generative AI as a technology? Okay, how many of you are using tools like ChatGPT, Bard, etc., right? Perfect. How many of you are actually trying to use it not for personal use like sending an email to your boss or welcoming friends, etc.? Are you using it for business purposes? Are you trying to embed as part of your business workflows, use cases? Quick show of hands. Perfect. So I think I get a good sense about, I saw a few hands in the last one, so I'll try to pace my presentation around these lines. So let me start with a quick introduction about where we think AI is going, right? So if you look at the technology itself, it is getting embedded in our daily lives. What we believe is that AI as a companion is going to be extremely prevalent going forward. And the previous speakers spoke about several such examples. And we strongly believe that we are already surrounded by AI. It's a question of unleashing the power of all the interesting things which we see in ChatGPT type of scenarios into our daily lives. We already are having wearables. It's collecting tremendous amounts of data. It can give you insights about your personal lives, right? Your health conditions, etc. And of course, you have people are leveraging AI for interesting interventions around learning and development in terms of understanding your learning path. Can I create a very, very custom learning path for a user based on all the inputs you have gathered from the end user to make learning very, very effective? And then there are interesting examples around manufacturing where humans and robots are working together hand in hand, right? So one interesting example I like to give when this AI versus human debate is that an AI plus human is always better than just the human alone or just the AI alone, right? So, and finally, mobility. We already spoke about mobility as several speakers in the past, so I'm not getting into mobility as an example, but autonomous cars, the level of intelligence which are getting built in and the level of autonomy is only going to get enhanced going forward. Okay, with that, let me start with an introduction about the history of AI, right? So the initial concept started sort of coming up in 1956, where we had the first conference organized by Alan Turing and all the others, where they spoke about intelligent machines, right? They spoke about intelligence way back in 1956. And over the years, there have been several key developments in terms of either LSTMs or RNNs or perceptrons over the period of time. So these are all been interesting step-by-step progress which AI has made over the last several years, right? Now, if you look at this time from 1956 to around 2013, AI has gone through multiple ups and downs, right? We in the AI parlance call it AI winters, which means that, sometimes the technology gets hyped up too much, right? And people expect a lot from the technology. It doesn't deliver. It goes into a slump, right? It doesn't get funding. And AI has its own fair share of ups and downs, right? It's gone through multiple ups and downs. For example, I'll give you a personal example. I wrote my first AI program in 1998. Right? Back then, there was this technology, we used to call it expert systems, right? So expert systems were nothing but if-then-else rules, right? You write, hundreds and hundreds of if-then-else rules, and then it sort of was called AI those days, right? Today, we call them typical rules engines, right? And now you can see today's AI, what we call as either deep learning or any of the diffusion models, you can imagine what people are going to call it 20 years down the line when the technology sort of becomes exponentially more powerful than what we see today. Now, key things happened the last 10 years, right? Last 10 years for AI has been a decade of exponential growth in technology, in open source, in data, in cloud, and most importantly, the community, which is contributing towards all of these. Now, the key developments, variational autoencoders in 2013. We saw GANs in 2014, which was a PhD thesis of Ian Goodfellow, right? He actually built the first GAN models as part of his thesis, and you can see, if you search for Ian Goodfellow and his first GAN models, you can actually see blurry black and white pictures of non-existent people, which that research actually generated. Diffusion models came up in 2015, and transformer architecture came in 2017. Transformer architecture has been the most fundamental technology lever for all the generative AI which you see today. And that was, and transformer architecture was a research which came out of Google, right? They wrote this interesting paper called Attention is All You Need, right? So that was a very, very fundamental research which came out of Google. But if you look at OpenAI and the entire ChatGPT team, they have been in existence from 2012, 2013. They were actually trying to figure out what should be their business model. They had a grand vision about large language models, but they never had the technology or the thought process to make it work. Transformer architecture made that possible. When they read the research, it was their aha moment. And OpenAI team actually saw this was the one technology they were waiting for. Now that is the beauty of the technology industry, where an innovation which came out of Google got adopted by a third party. They started building something phenomenally wonderful, even getting a leg up on the original inventors of the technology, right? So that's when they actually, look at how fast things are moving from 2017 to 2018. They actually launched the first GPT in 2018. It was not available for public usage like ChatGPT, but it was available for people to experiment, right? That's when actually OpenAI launched the first version of GPT. Then DALL-E was launched. DALL-E is the image generator from OpenAI. And then whole lot of startups started coming in. And these are startups who are giving you images, they're giving you outputs, which are, you go to Mid-Journey and you can play around with, or Stable Diffusion, you can generate images of various types. And many of them are, giving serious concerns regarding the copyright, of the people, the privacy of the people, and all the other related complexities. And today, we have GPT-4, and just 2 days back, they just launched GPT-4 Turbo, which is going to be GPT-4 amplified, right? So this entire industry is changing so fast and so furious that it is very difficult for us as industry practitioners to even keep up with all the new developments happening in this industry. Now, so this is an image of the time it took companies to reach 100 million users, right? Now, if you look at Netflix, it took 10 years for them to reach 100 million users. ChatGPT took 2 months, right? So you can imagine how fast things are moving, right? So you can, I won't be surprised if something is launched in the future which will probably beat this by hands down in 2 weeks or even shorter duration. Now, the key technology or the key development which is driving all of this is data. And the previous speaker spoke about data extensively. I'm not getting into that again. But the key point to keep in mind is that 90% of all the world's data is collected in the last 2 years, right? That is the amount of data we're all generating as human beings. Be it the image you're sharing in WhatsApp, or the email you're sending to your managers, or any of the other content you're creating, we are almost creating 90% of all the world's data every 2 years. And this is going to get shorter and shorter. It'll probably be 2 weeks in the next 5 years or 10 years. That is the level of data we are all generating as human beings. And of course, there is 2.5 quintillion bytes of data generated every single day by all of us. Now, these are the key trends I'm going to talk today, right? So if you look at generative AI, this space is going so fast, and there are so many new developments happening on a daily basis. It is difficult for us to keep track, but these are trends we see as of now, right? So this might change as we progress, but I'm going to cover some of this, in the next 15 minutes. Okay, the first trend we are seeing is that the models are getting more and more complex, and the next one is around multimodal AI. Now, if you look at the models becoming bigger, I'm talking about parameters, right? So if you are not comfortable with parameters, just go with this broad concept of parameters, but you can look up on what parameters are all about. It is a difficult concept to understand if you're not getting too familiar with it. The whole idea here is the models are learning from more and more data, and the parameters, for example, there are models like GPT, which has got 1.7 trillion parameters, and then there are other simpler models with several billions of parameters. The more the parameters, the simple equation is the more the parameters, the assumption is the model is learned more from real life concepts. Therefore, it is able to answer or able to solve more complex questions, right? Now, if you look at GPT-4, it is a monster model, right? So it's got around 1.76 trillion parameters. As against GPT-3 and 3.5, 3.5 had around 175 billion parameters, and 3 had around 1.5 billion parameters, right? Till about 4 months back, we were using GPT-3, and now it is GPT-4, which is like 1.7 trillion. So it is got not just text processing capabilities, this is also got multimodal capabilities. By multimodality, I'm talking about the ability of the AI models to not just process text. It has got the ability to process text along with video, along with images, along with audio, right? Multimodality is a very, very interesting trend which we see happening as we look at this industry. It is not just one form of data, it is multiple data points which you're able to analyze. If you look at a CCTV camera, typically people are looking only at the images and making inferences. But at the same time, it's got data of audio and all the other things which are coming in. So multimodality is going to be a very, very important concept for generative AI going forward. The next interesting trend is transfer learning and few shot learnings, right? So transfer learning is a concept where you train a model on a certain set of data. The model is learning from that particular set of data. It is drawing its inferences. At the same time, you're leveraging that inferences on a certain different concept, right? So this is where the power of the industry comes in, where collectively a lot of us are building models, foundational models, open source models, etc., and you're learning from that, and you're essentially leveraging the learning of these models to apply in a completely different context, right? For example, a very, very simple, dumb example is a model trained to identify cats on a road can be tweaked to identify some other animals with certain different dimensions. The next interesting concept is few shot learnings or one shot learnings. So few shot learnings is a very, very interesting thing where traditionally we used to depend upon large amounts of data and training these models on large amounts of data. Few shot learning and one shot learnings are emerging where you're able to train the model with very few data sets. We see a very, very similar trend when we work on quantum machine learning for image analytics, where the engine or the model is able to learn with very few images. It is able to learn a lot more parameters, which means that you need less data points for the model to learn going forward. The next one, and the previous speaker spoke about this multiple times, is responsible AI, which is going to be extremely critical because traditional machine learning models, the old ones, have certain degree of explainability built in. You can actually query the model and find out why the model took a decision. If you look at deep learning, you don't have that. If you look at diffusion models of the type we are talking about, GPT, etc., they don't have any explainability, which means the model is not able to explain why it took a certain decision. So if the model is not able to explain a decision, how can a human being who's depending on the model to take a decision based on that trust the model, right? So a lot of associated things come in terms of explainability, bias in the data and bias in the model, bias in the human beings who are programming the model. Then there are issues with regard to interpretability of the model, and of course all the ethics behind it, which is very, very important, because when you're looking at AI developers or AI engineers, you need to be not just training them on technology skills, but also soft skills and ethics, because otherwise garbage in and garbage out, you end up building models which are completely having a completely different dimension of ethics and morality compared to real life scenarios. This is very, very interesting because if you look at many of the traditional models, and if you look at various data sets people use, like people use AlexNet and various other ImageNet, etc., recent studies from MIT and others have shown that many of these data, which we all rely as ground truth, has significant bias built in, which means that many of us as AI researchers and practitioners need to question the bias of any data which comes in. So this is a good example about somebody asking a question about a color photograph of a housekeeper. So look at the images the engine has generated, right? Obviously you can make out it is biased. Then there is this entire concept around understanding of language, right? Enhanced text understanding, enhanced language understanding, and privacy preserving algorithms. Language understanding is extremely critical, and today, many of the AI models or large language models are called stochastic parrots, which means that they just goggling out information. They don't understand the context. They're just learning from a pattern and giving you the answer. Increasingly, they are going to be much more intelligent going forward. And privacy preserving. Privacy preserving is very, very critical because many of the times you find these cameras all over the place. I don't know how many cameras I saw today morning in Trident. Have you ever imagined who is going to see this data? Every time you go to a hotel, they ask you for an Aadhaar card without blinking an eye. All this data is going somewhere. God knows who is going to use it. So that is going to be extremely critical. If you have a video camera, you should have mechanisms to ensure that that data which is captured, which is my privacy data, should be scrubbed, ideally not used at all, right? So these are going to be extremely critical for building models which are preserving the privacy of the end user based on whom the data has been, the model has been built. We'll have more and more of customization and personalization. We'll see more adoption. There are several industry scenarios which are prime for disruption using generative AI, and you'll see more and more of very, very interesting use cases and business models emerging in this space. Personalization, I spoke about personalization, and this is where the whole concept, I spoke about transfer learning and learning from existing foundation models and leveraging that learning in other contexts play a very, very important role. And this is where the whole concept of private large language models are emerging. Now, private large language models are models which are essentially customized and trained on your own data, right? If you use GPT or ChatGPT or Bard, many of the times you must have wondered, this is good at answering global questions, but it can't answer a question about my data, my use case, my company's data, which is lying in tremendous amount of systems. This is precisely where private large language models come into place, where you build a large language model on your data, which is able to answer questions which are extremely relevant for your industry, your context, or your business use case, right? Private large language models also have a number of advantages in the sense that you can have very bias-free data because you have trained the model on very, very unbiased data. It's your own company data. It is not going to a third-party system. It is not calling an API. And it is also you have complete control over the entire model pipeline, which means that you have mechanisms for you to tweak. This is where open source foundation models come into play, and you can leverage open source models like Llama or Falcon or any of them and build extremely targeted private large language models which can answer questions specific to your industry. I'll give you one example of a private large language model. So this is something which my team built. We call it Health GPT, right? Healthcare is an industry which is primed for disruption given the large amounts of data the industry generates, right? So what we've been working on in private large language models is to build a very, very custom private large language model for one industry. We picked up healthcare as a domain, and we collected large amounts of data on the clinical trial side. As you know, if you're in the healthcare space, when you're inventing drugs, you generate tremendous amount of clinical trial data and all the other related stuff. So we use that clinical trial data to build something what we call as Health GPT. We built it using one of the open source models out there called Falcon 7B, and we customized and built this entire model, right? So one of the first models in the private large language models to come out of India. And this is something which we are testing out with a number of our customers. So the whole point here is that not just leveraging OpenAI and other tools and just looking at the APIs, I'm asking all the audience here to explore beyond, because if you're just calling an API, you're only looking at leveraging what is existing. But looking at concepts like private large language models will open up new innovation opportunities for you. It will open up new business models for you. It will open up new ways to unlock value from all the data you have in your industry boundaries, right? So it can answer intricate questions. These are examples about very, very complex, intricate questions. We are asking the model about breast cancer, of diseases like heart diseases, etc. And the model is able to answer very, very precisely all the complex questions we are asking. Finally, so this is a snapshot of, in the interest of time, I'm not getting into this. So this is a snapshot of how we went about building the entire private large language model. Happy to jump into a conversation in coffee after this. But whole point here is there is a lot we can do using the open source technologies, and this is a vast new area. And like Bhimsen said, we are probably the most exciting time as far as AI and generative AI and all the technology is concerned. Last slide. This is how we go about building a private large language model. You start with the data, look at the data, identify the biases in the data, decide on an architecture. In our case, we went with transformer architecture, choose an open source building block or a foundation model, train the model, test it, and validate it, right? So I take a pause. Happy to answer any questions you have now or over coffee.
Thank you, Dr. Jay Ganesh. That's a wonderful session. really intriguing, and the slides are also very wonderful, and we got so much of deep dive into the tech that you are doing. Now, I request Mr. Srinivas Raju, CEO of Pi Square, to felicitate Dr. Jay Ganesh.
Thank you so much. Thank you. Thank you. Thanks.
We have a short tea break for now, for 20 minutes. We have more exciting sessions after that. Please be on time. Thank you. Everyone? So we have seen great discussions in the first half. We have seen a lot of use cases that requires a lot of NPU, power, compute, and then we have seen we need 5G to process or to get that much data. So all these indicate that we have a lot of work going forward and a glorious future. With that note, we will start a panel discussion. We have moderator LK Reddy. He is going to take us AI for all, enabling technologies for accelerated adoption. So LK Reddy has a skill set in machine learning, camera, video conferencing, wireless technologies, device drivers, device signal processors, and system on chip. Strong engineering professional with Master of Technology from IIT Madras. So please welcome LK Reddy, Senior Director, Qualcomm.
What's your reflection?
So we have other panelists, Mr. Ashish Kushu, Chief Technology Officer, L&T Technology Services, Xavier Kurian, Director, Pre-Sales, Dell Technologies, Dr. Shailesh Kumar, Chief Data Scientist, COE AML, Reliance Jio, Dr. Ganesh Ella, CTO, iHub. I request all other panelists to join us on the stage. I'll hand over the stage to LK Reddy. Thank you.
Good morning, everyone. So today we have a very interesting topic, AI for all. So every day, whenever you go buy something now AI is coming everywhere. You go buy a washing machine or refrigerator, they say AI enabled from AC to refrigerator, or you take a picture in your mobile phone that runs up 50 AI models to make a good photography in a low light, or you go search something in the Amazon, it runs a lot of models to make it. And also a lot of productivity applications, AI is coming into it. And so it impacted multiple ways our life. And there are many other ways where this AI can go, especially with the different enabling technologies coming in with generative AI. It can impact many more other industries. So today we have a very experienced panel who are touching at different facets of how AI is impacting the different lives and the different sectors of the industry. So I'd like to introduce the panel. Yeah, Mr. Ashish Kushu is the Chief Technology Officer in L&T Technology Services, and he drives the company technology and innovation and develops the IPs and the solutions related to that. And L&T Technology Services is India's largest pure-play engineering service company, and their innovation is recognized across the industry. So welcome.
Thank you,
Ashish, and looking forward for more insights.
Yeah.
And next, I would like to welcome Mr. Xavier, and he is a Director of Solution Architect and Pre-Sales team at Dell Technologies, and he is responsible for leading the team in driving all technical engagements at Dell Technologies. So, Mr. Xavier has 23 years of experience in IT, and he led transformative projects across the customers in different industry verticals. Yeah. Welcome,
Thank you.
Xavier. So we have Dr. Shailesh Kumar. He's a Chief Data Scientist at AML Center of Excellence at Reliance Jio. He's focusing on new ways to impact education, agriculture, healthcare, and mobility in the era of digital connectivity and AI. He has over 20 years of experience in building and innovating AI/ML solutions across the wide variety of domains. And he has a deep expertise across AI, ML, deep learning, reinforcement learning, natural language processing across the years. And he's also eminent speaker at different forums like TEDx, NASCAM, across the different tech companies and startup forums and the universities. Welcome, Dr. Shailesh. And we have Dr. Veera Ganesh Yalla. He's working as a Chief Technology Officer at iHub Foundation at IIT Hyderabad, IIIT Hyderabad. He's focusing on enhancing the research and deploying solutions in data banks, data services, and data analytics. So he has over 17 years of experience across the AI, ML, automotive, sensors, and these areas. And he has 30 granted patents. So yeah, welcome Ganesh, and looking forward for your side. So yeah, like we said, the topic is what are the technologies which are really making a accelerated adoption and taking it across. So I'm using one slide from NASCAM which shows the whole spectrum of technologies which are impacting. So if you take on the top row, we have multiple semiconductor companies like where I host from Qualcomm, NVIDIA, AMD. They are building the edge computing and the cloud computing related GPUs and the related AI, ML accelerators. And then we have different cloud players like Amazon, Google, Microsoft, Alibaba, and others who are helping to take these GPUs or the technologies and a lot many and taking it into different things. And we have foundation models which are the key, and they touch every spectrum of the areas where it will impact our lives, from large language models to text generation to cameras, video, image, and assistants and other things. And the next, third, and fourth layer are the ones where really all these foundational technologies are taken into the commercialization and make impact into the lives of the people. So that's where there is a big play, and hundreds of companies are playing, impacting every domain from technology to finance to healthcare to agriculture to how we code, how we write our mails, or how we create our content. So it's impacting everywhere. So with that note on AI for all, enabling technologies for accelerating the adoption, yeah, I would like panelists to, what do you think are the key enabling technologies in your view, which is making this proliferation of AI across and impacting more lives of the people?
Thank you. Pleasure to be here. We already had a very animated discussion. So this is a topic where, there are lots of opinion and there are some strong opinions, and I think I belong to the set of people who have a strong opinion. What qualifies me here, first of all, is that we've been working on AI since 2016. That's the nature of business that we have. We cater to the engineering and R&D heads and CTOs and VP R&Ds of engineering companies across, and they technically would love us to be more deeper in some of these things. So that's really what my function is. So before I come directly to what LK asked me, one very important aspect of this discussion and the hype is an English term called peeling the onion. Since all of you are from the technology field, I think that's very important, that we need to peel the onion slice by slice or cover by cover. Only then do you get down to what is going to be the impediments, where will it succeed, what will make it succeed, what are the governing factors, enabling factors, and at what point in time will it succeed. So our 6-year journey got accelerated by working on LLMs for the last 3 years. Based on that, and we also worked on embedded AI for 3-4 years now. Actually, we worked on embedded AI a lot more, and that's the quantization, pruning that Qualcomm is talking a lot of, and we completely agree with what they're talking. So we believe that a couple of things why this will become a big thing, what are the enabling technologies here, is the fact that you have compute which is very cheaply available. Very cheaply available. Now, which means that compute at the edge, CPUs, and at the cloud, very cheaply available, and that's really out of the box. Second is that technologies have matured. And I really don't get fascinated by LLMs and Gen AI. I mean, that's okay. This is noise. There are many other technologies in the space of AI which have actually matured and have come to a stage where they can be applied. Not everything needs LLM and not everything needs Gen AI. There are many technologies which can solve the complex problems that you have. So that's the second enabling thing. And the third most enabling thing is our friends from Geo and other organizations. They have agreed to start using data and sharing data. This was not the case 3 years back. It does not matter what compute, GPU, and everything else you have till you don't have the right type of data. How long will you work with synthetic data? And I can tell you for 6 years working on synthetic data, it just gets you nowhere. Organizations have agreed to share data. And that's very important. That's a cultural shift that is happening. And not only people like Geo who have their own team, which is fantastic. There are many organizations who are sitting on this. And that's really the emerging, these are the things which are, some of them are non-technical, but these are the ones which I think are enabling. And just 5 seconds more. Unknown to many people, when they talk of LLMs, they forget that one of the best LLMs out there is a Bloomberg LLM, which is financial data that Bloomberg has used. LLMs have to be domain specific, and you will get domain specific good LLMs if only customers and organizations who are sitting on this data make it available. And we've seen that shift happening 4 years back, 5 years back, nobody would even give you an access. Forget to us, to internal people, but now it's happening. So I think these are 2 or 3 things that are really helping and will accelerate as you go forward the adoption of AI.
Yeah, thank you, Ashish. Yeah, since we are talking about data, and that's one of the key fuel for driving the AML adoption, maybe I want to ask Dr. Ganesh and Dr. Shailesh that order to share your views because you are working big on the data, and what are the key enablers and how it's trending, and yeah.
Sure. So I can go first. So data is the key for any AI development. So without data, there is no AI, ML, that's kind of understood already. So we are, especially like my organization is focused on creating India-specific data sets. By that we mean, if you look at all the LLM models, for example, right, or even like ChatGPT, they are actually mostly have a data bias. So they are designed around certain text or knowledge that's been fed into the models, where it is mostly like westernized data. Again, nothing wrong with that. I mean, that's where the innovation is starting today. But if once you come to why is there not like a Bharat GPT, or why there is not like an India-specific GPT model yet, that depends on data. So that's the key part, and that's what we are trying to enable. And I think this is happening, like Ashish mentioned, right? Organizations are starting to realize the importance of making this data accessible. So today, like at least from iHub side, we have mobility data, that is Indian driving data sets that we have published already. A lot of startups are actually leveraging that data and building some new innovation solutions. So that is actually happening. And similar on healthcare, we are collecting lots of data. Not all of it is available in public space yet, but you can still log into our data foundation and actually see the data. Just giving as an example, not trying to market iHub or anything. So the key aspect is how do we make the data sets available for the mass public? There are a lot of brilliant researchers out there who can do phenomenal stuff with the data. If you give them the data, they can build some very interesting AI models. If you run some challenges, they come up with some very interesting insights that you probably wouldn't have even thought about. So that is one of the key things. Data is becoming more and more accessible. There are platforms, that are available today where you can go and get the data like Kaggle, Hugging Face, RoboFlow, so on. Just some examples. Where you can actually go try out be part of a challenge, try out new ideas, come up with new solutions, and I don't know how many of you know about the DARPA challenge, the defense challenge that happened recently. I think it's called XView, where they just published like tons of satellite data and said like, come up with a solution where you can detect dark ships. And number of interesting solutions have come in the challenge. And I think a couple of them are actually being converted into startups as well. So this phenomena is happening. So I think data is the key thing. So making the data accessible to the masses, I think that is the key enabling technology, at least from my perspective. I'll hand it over.
Yeah, so just continuing on that for a few minutes. So I think this is like a tale of two cities, right? There are some areas where we have lots of data. If you look at Amazon, Netflix, Google, the digital world, and there's the other side, which is the physical world, right? If you look at education, every kid doing a homework on a notebook, we're not generating data, right? Every farmer growing crops, taking the logs on their register, we are not digitizing that data. If you look at healthcare, doctor writing a prescription on paper, printouts of everything, we are not digitizing data. So to get to a good data civilization, especially in the social sector, one of the key enabling technologies would be digitization of data, right? And earlier when devices were made, MRIs and all that, they were meant for humans to consume that data, therefore printouts of everything. But today we are transitioning from human is going to consume data to AI will consume data. Therefore, all data has to become AI first data, not human first data. There's a very big transformation that has to happen, right? Wearables, automatic, ECGs automatically goes to AI first. X-ray goes to AI first, then to a radiologist. We have to change that workflow completely. That's a very important transition that will happen. And I think on the data side, that was my thought. The other is, what is data? A lot of people think that data that is generated is the only data, right? But knowledge is also data, right? Storing the knowledge of the domain, what medicine treat what disease is also data. Knowledge is data. Labels is also data, whether it is created automatically or not. Features that you are generating from raw data is also data. Decisions you have taken in the past is also data. Feedback you are receiving from others outside is also data. So when we think about data, I think both as a technology, data layer, as well as the notion of what is data has to kind of keep evolving. And I think we're still evolving on the data layer. Compute layer, we are very ahead. Connectivity layer, we are very ahead. Data layer is still evolving. And AI layer also, very ahead in some places, but behind in some places. But it's a beautiful time to be around. It's a convergence that is making the magic. And I think seeing all kinds of people in the room is what is exciting about this conference.
I just want to add to what he said. Sorry, that's really the peeling the onion. So just two examples. Just when COVID hit, we built a solution called Chest RAI to detect the lung disease and figure out what is COVID. Number of X-rays available to train the model. Model, AI, medical model, no problem at all. X-rays available, 500. 300 from the WHO data set. 130 somewhere here, there in open source, somebody had loaded. This as early as 3 years back. But now you go back, they say, yes, let's give you. So that's a dramatic change that has happened. And just to pick up on what he said, we have a very unidimensional view of what data is. If he talked to a company which is an oil exploration company, they have data for 100 years. Digitize that data means written in handwriting forms, written on paper, which has got deteriorated. The data for this building would be in physical forms, in A4 size, A0 size, in all type of drawings. So this awareness about data is there. The layering of data and getting it together is very complex. There are technologies, but as we said, I think we are converging on that access to this data, digitize it and use it is a dramatic change that has happened in the last 2-3 years, right, sir? And that's really what is going to propel it forward.
That's a good point, sir. We touched upon on data, mainly the data availability, how we'll make it, and what are the key challenges. And somewhere we have more data, somewhere less data. So there are a lot of things we need to evolve yet to make this data accessible. While data is fuel, the engine which runs is the models. So there are a lot of models which are happening, and with that, and to deploy those models, we need.
LK, you should remember another thing, that it's not getting the data is one piece, but there's also the piece of going and how to go manage that data, how to go share that data, how to go make that accessible for the compute that is required today. And all of those technologies as well have evolved over the last few years. Today, like Ashish said, yes, compute has come down, price of compute has come down significantly, and that's one of the biggest enablers. If you had asked me to go run one of these models 5 years ago, it would have been cost prohibitive. Today, it's possible to go run it because the cost of compute has come down. But when that compute is available, you also need availability of data, availability of connectivity, how to go share this with multiple data sets, how to go create methods of collaboration where you're not really sharing the data, you're sharing outputs. And all of those technologies as well have evolved. So it's a coming together of many things, of the willingness to share data, of the ability to share the data, the technologies that are required for it, and the compute. That is really what has resulted in the hockey stick.
Yeah, that's a good point, Javier. Also, even though the compute is improving, the models and the complexity is exponentially increasing, and there is a more and more need to make this compute energy efficient and also available for everybody. Also, the trend is moving towards the edge, and whatever that number of tops we add on the edge, that's becoming, whatever the fast pace you do with the hardware, software design, still we are seeing there is short of the compute power. Yeah, that's a good point. And with that, also I want to hear from models, how the different models, foundational models are helping to proliferate this thing and making AI more useful and more accessible for everybody. Maybe, yeah, Dr. Shailesh, you want to throw? And
so I'll talk about the pros and cons. So I think the LLM models have suddenly changed the world in a very different way. It's like saying the librarian that we used to have called Google Search has now read all the books. So it's not pointing you to a book and saying, go find your answer there. It's telling you the answer because it has read all the books. So that is what a big change is. We are still accessing information. Accessing and transmitting information is a bedrock of any civilization. We have been doing it for 10,000 years. We used to recite shlokas and transfer them. Then we used to write them. Printing press came, then internet came, Google search came. Now Gen AI has come. It's just an evolution of how we store and communicate knowledge of the world. So it's a very beautiful progression. Now, sometimes technologies drive use cases, sometimes use cases push technologies. And we are going to see this, right? Suddenly now it's like climbing a hill. You keep three things constant, one thing move. So now AI technology as a technology has taken an upper hand. And now we are seeing a lot of applications coming in. Healthcare, education is going to be disrupted. One of my predictions is that AI is going to be a co-pilot for a researcher who will win a Nobel Prize, and it will be a co-inventor in that research. And this will happen once every hour. And that is what is amazing about AI, right? So I'll just give you an insight about this. To do a great research today, somebody has to read many documents, connect many dots, remember everything. Suddenly an insight will come. This is a very serendipitous process of how research happens today. Now imagine AI has read all the documents, it has connected all the dots, it doesn't sleep, it doesn't forget, and it's constantly proactively looking for patterns in that network. That would completely change the way we think about the next thing that humanity will do, will be, finding cure for cancer, discovering new drugs, all that will happen. Today, if you think about education, right? Today, the textbook is the same for every child. But what is going to happen now, if I say I am a fourth grade student, I need to learn this topic, teach me at my level, but I want Madam Curie to teach me the chemistry, not my chemistry teacher. And it will generate content for you at your level, the way you will understand it. Compare that to the static textbooks that every child has to read today. So the amount of disruption, this is going to be a new innovation, how we are going to take this technology and highly personalized content generation, whether it's for education, for, imagine a farmer asking, how should I spray my pesticide? Imagine AI will generate content on the fly for you instead of retrieving something, right? So I think we are going to go from retrieval to generation world very quickly, and lot of things that we used to do the old-fashioned way will change, and the role of humans will be curation, not creation anymore, right? And that's where we need to think about our role in the new world.
That's a good futuristic observation. How far we are towards that? Means generative AI to...
I'll add a little bit about what Dr. Shailesh said. So today, every one of you have already touched some AI or the other, and I'll give you a couple of examples, right? Today, if you open any app on your phone, there are advertisements. Imagine being able to get that advertisement that is so accurate that the probability of a click is extremely high. It's money for the app developer, which means that the app is going to be better. There's advantages for you as well. I'll give you the other side of AI. Today, AI is being used along with weather pattern models to detect where rain is going to happen. So the future is to be able to say, hey, by the way, this plot of land is going to get rain on next Wednesday. You might as well spray a pesticide today and then than on Monday, because if you spray it on Monday, the pesticide doesn't have enough time. Improve crop yields, improve usage. Everything that we are doing today has some bits of AI sitting there, right? The world is an oyster. That means it's only going to get more pervasive.
So since we are talking about models, and Ashish, you did a lot of work on LLMs, can you throw more light on what are the recent trends and the challenges and how you mitigated to get them working at the best and the comparative study?
So before we come to that slide, I've just got a slide on LLMs and model optimization. I think I will just pick up on what Dr. Shailesh said. If you have to broadly classify from our perspective, and as I said, I don't come from the commercial, financial, retail business, I come from the engineering set of folks. It has been tech first so far, but that's it. That's it. It has to be domain first, and that's the transition which is happening. Tech has a role to play till a certain point, and we get fascinated about a tech lot because of various other reasons, including the economic prosperity that we've got because of being tech masters. But it is to be domain first, and if AI has to go there, it has to be domain first, and that transition has sort of started happening. That's item number one. Now, item number two is LLMs are not a panacea. Oh, ek LLM, we'll use one LLM, it'll solve everything. Go to the earlier slide if you don't mind. I'll just show you, you will have a solution which will have LLM for as fine-tuned a function as you would want to have, right? Which means the solution can have 20 LLMs. So just get deeper and deeper and you'll realize what is the type of immense possibilities that you have. Now, I've just not taken something, I've just taken a very simple example of digitization of something that we were doing, and we've listed down only 2 or 3 classes. There are 30 such classes, and every class has feature. For example, text extraction, text substitution, font size, line size, this size. We took GPT as one of the best and did the comparisons with all others, and you'll see some LLMs are good in one, some are good in something else, and something is good in something else, and then Llama is better in some, but Llama is not good in others. So what should your strategy be? Not LLM. Which LLM? What will drive your adoption strategy? What is the use case? What are you trying to solve? That is the starting point of a discussion. What is it that you're trying to solve? What is the workflow? What is the expectation? Break it down, then figure out, and then apply LLM, and then that's when you get the right usage of the power of this technology. Now, if you go to the next slide, you will also see, as I said, I've just given a very small, very minute. Here you will see how LLM usage is just a very small part. The next part is how do you optimize LLM for the cost and for latencies. You just can't take an LLM and say, I'll use it. You again need to figure out 32-bit, 64-bit, how much memory it takes, what is the compute, etc., etc. And then you go to the third slide, which is my favorite slide. If there is something that will drive AI adoption across all layers, it is the type of work that you've done here. And we've taken 3 models and we filed patents for that, for model optimization. And you see, the accuracy comes down, but the cost of MB and MFLOPS is tremendously low. Now, this is a design criteria which is not in the hands of the engineers. It is the business guy. The business guy among all of us is Dr. Shailesh. He's to take that call. Where do I compromise on accuracy and cost? So when you are talking LLMs and when you're talking model optimization and you're talking of a hybrid infrastructure, we envisage a position where they have tremendous potential in areas where they have to be applied. Not everything needs LLM. Not everything needs Gen AI, but you get them to the right place, the power is absolutely fantastic. Having said that, the deployment strategy also changes because of this third slide, which is model optimization, quantization, pruning, something that Qualcomm is working and doing excellently well. Now, these are the type of challenges that have to be solved. You don't solve these problems, somebody else will, for the simple reason that AI is here to stay. Not because I love it or you love it, because you are in a connected world and connected world produces data. And what the hell are you going to do with that data? Analyze, and then what more? Intelligent analytics, right? So how will you get intelligent analytics? It is this. So this is an imperative. So to solve these problems is really LK the key. You get deeper into this, driven by domain, what use case, you get fitted there. The power is absolutely immense. I'll give you a very simple example. And the large number of services business in India is driven by test automation. Now everybody says we do testing. Everybody says we do test automation, including Qualcomm and many other customers here. I heard a speaker from Harman as well. But what you do in test automation, auto test script generation, that's a max, or log analyzing. Try using LLMs and you'll see you can take a requirement document and it will take you right through execution. Every phase automated using LLMs. Now imagine the cost reduction, 70 to 80%. But how do you do that? Access to data. If an OEM gives us that data, you use LLMs to do it, 80% reduction within 3 months. So this is the type of challenges, LK, we are seeing when you look at adopting AI.
Thanks, Ashish. So to deploy all these models, we need a lot of compute power and there are a lot of challenges. Javier, since you're from Dell, can you throw more light on what are the key challenges? What are the trends helping them to deploy more and more the AI?
So one of the first things, and while cost of compute has come down, the complexity has actually only gone up because the amount of data, number of sources of data, how are you going to aggregate all of this data? There was this big phase where data lakes started getting created. A lot of companies have gone and done things around aggregation of data, but you've got to go manage that data. You've got to go operate that data. The easy way is to go hire it off a cloud, and almost all the cloud service providers today have some amount of GPU compute that's available on the cloud. The more cost-effective way is to go build it yourself, right? To go build it in-house. And anywhere where we're seeing large-scale adoption, we're seeing clusters getting built in-house for a lot of these use cases. While that gets done, you have to also go build the method by which you're going to collect the data, go store the data, archive the data, or go do improvements, or where you're going to store the tuning pointers. There's a whole bunch of thought process on that, and each one of that is complexity. But yes, the technologies exist, and it is progressing at a phenomenal pace.
Yeah, thanks, Javier. So if audience has any questions, please come to the central camera and we'll provide the mic and you can ask the panel. Meanwhile, I just wanted to...
I just want to talk about two important themes. Can you put the
So we'll
slides
switch
on?
to... till now we had multiple use cases which is impacting our lives. Now Dr. Shailesh and others are trying to expand AI into multiple other domains which are not touched, which are India-centric. So I just wanted to talk, Dr. Shailesh, about those.
So basically, in the last 20 years, we have seen the use cases of AI in mostly commercial sectors, right? Netflix recommendation, Amazon, search engines, ads, sales, then supply chain. And now we are going into social sector. So the next 20 years of AI will be very social sector transformation of AI. If you go to the next slide. So the idea is democratization of technology and democratization of AI is going to be a big theme. Not only a few people will do AI, everybody should be able to do AI. And the idea is, if you look at the slides, there are so many sectors that need so many types of AI models. And now, in Indian context, so many languages, so many domains, language cross-domain, language models, if you will.
Sir, will you make a large language model?
Huh?
Will Geo make a large language model? Is that in your plan?
Within our domains, we are, right, for telecom domain and others. Awesome. And now imagine all the agriculture knowledge available out there, right? Medical knowledge available out there. But it's available in English language. But the farmer needs it in Telugu, Tamil, and Punjabi. So there's a whole bunch of work that needs to be done. And the idea is, how do you create an ecosystem of AI in India through government, through startup, through big companies to do that is one theme that I think as a country we should move forward. Second theme is we need to raise the level of the way we think about AI. We think about one model, one deployment, one use case, one scaling. But really, if you think about the operating system level thinking for agriculture, education, and healthcare, right? What should come in as events? Many, many things happen and many, many outputs have to go out. How do we create these operating systems is going to be a next big layer on top of it, right? Model thinking to ecosystem thinking. Many types of events coming in, many types of actions going out. Whether you take healthcare, just if you can just skim through. And there is a simple, very common design pattern in this. And I think if we work at this level of abstraction now, work top-down about AI, not just bottom-up in AI, then I think we'll bring the domain and the application first thinking and work backward and pick the right technology for the right thing, not LLM for everything. Thank you.
Yeah, thank you. That's very insightful and looking forward for next 20 years impacting more and more people's lives. Yeah, we have a lot more interesting insights to share, but we are running out of time. Thank you for all insightful inputs from all of you. I hope it helps many of them to take it, how they can scale the different domains and areas where they can scale and how they can scale into multiple models and not get hyped by one or two, and also some insights on how we can solve the data center problems and installation or implementation of those things. Yeah. Okay. Thank you, everyone.
Thank you, well.
Thank you, everyone, for the very interesting discussion. Now, may I request Mr. L.K. Reddy to felicitate our panelists. Can we have a huge round of applause for all the panel members? All our panel discussions are going so deep that they are even crossing the time limit all the times. Now we have another panel discussion coming. So this is about AI ML for healthcare. So this is moderated by Mr. Varma Konala, CEO INAI, Business Head Smart Devices Intel. So 26-year Intel veteran with the first 5 years in design, testing and validation, followed by 21 years in all facets of marketing. Majority of his business side experience has been in a startup-like environment handling multiple responsibilities, taking products from conception to revenue. He is currently on deputation from Intel as a CEO of INAI, the Applied AI Research Center in IIIT Hyderabad. This is a public-private collaborative effort between Intel, IIIT Hyderabad, PHFI, and Government of Telangana. Please welcome Mr. Varma Konala. So we have other panelists, Dr. Nitin Jagtap, consultant gastroenterologist at AIG Hospitals, Mr. Kalyan Uppaluri, co-founder, managing director, K&H, Personalized Medicine Clinic, Mr. Sunil Madhikatla, founder and CEO, Blue Semi, Mr. Suresh Muniswamy, deputy director, Health Informatics and Technology Innovations at PHFI. I request all the panelists to join us on the stage. I hand over the stage to Mr. Varma. Thank you.
Thank you. Morning, everybody. So you heard a lot this morning on AI in lots of areas. So we'll get a little bit deeper on AI in healthcare, right? There's a lot of stuff happening on AI in healthcare over the last 10 years, right? There's a lot of anticipation, there's a lot of excitement. There is some fear too, right? So prior to this role, I used to develop an AI marketplace for hospitals. So I used to talk to a lot of doctors, a lot of healthcare professionals. And one question I used to get, whenever I had conversations is especially radiologists, right? Is AI going to replace us, right? And my answer used to be the same for all these things. AI won't replace anybody, but doctors using AI will replace doctors who don't use AI, right? It's the same thing in every way, right? So we have a very, interesting panel here. They bring 4 different unique perspectives on the healthcare domain. So let me introduce them, right? I'll start with Dr. Nitin. Right? Dr. Nitin is a senior consultant at AIG Hospital with more than 10 years of experience. He has a special interest in clinical gastroenterology, advanced endoscopic interventions, endoscopic ultrasound, and metabolic and bariatric endoscopy. Right? He has numerous original publications in international journals and also an editorial board member of a journal of digestive endoscopy. Right? I think that's emblematic of a lot of people at AIG, where there's a lot of emphasis both on clinical practice and research. Welcome, Dr. Nitin. Right.
Thank you.
Then we have Dr. Kalyan Uppaluri, right? He's a distinguished and medical professional with a strong background in internal medicine and a commitment to medical education and community service. He's the founder and managing director of K&H Personalized Medicine Clinic. It's the only one of its kind that I know in Hyderabad, and he'll talk more about what he's doing, right? And he's been at the forefront of innovative and personalized healthcare in Hyderabad. Welcome, Dr. Kalyan.
Thank you.
Then we have Mr. Sunil, right? He comes from a different background, right? He's the founder and CEO of Blue Semi, and they have recently unveiled the world's first health tech gadget called AIVA that can measure 6 key vitals non-invasively, including blood sugar, right, in just 60 seconds, just by touch, right? So he's a unique background of 9 years in entrepreneurship, technology, and strategic planning. Welcome, Sunil. Right.
Thank you.
And my 4th panelist is Dr. Suresh. Dr. Suresh Muniswamy is a medical doctor, scientist, and startup entrepreneur. He is currently a deputy director and additional professor at PHFI for technology innovations. Right. He's over 10 years of experience in design, development of comprehensive software and using technology in primary healthcare, right? So he spent a lot of time in primary healthcare, and the platform they have developed called Comprehensive, right, is being field tested in several locations. He's about 10 design and process patents to his credit. Welcome, Dr. Suresh. Right. Thank you. So you can see, right, they come from various different backgrounds. So I want to give the floor to them first to give their initial impressions of using AI, ML in the domain that they're working on, and then we'll get into a discussion. We'll start with Dr. Suresh because he deals with primary healthcare, and that's the first touch point. And in our country, unless we fix that area, the rest of it, right, even if we fix those areas, first we have to fix the primary healthcare. Dr. Suresh.
Thanks, Verma. Well, everybody talks about domain, so I'll also explain the context that I'm actually working in. Our idea is very simple. Universal primary healthcare at home. The challenge here is primary healthcare is 1,000 microservices, and universal basically means you stay at home, we'll come to you. Not the other way around, which is happening, which is people coming to facilities. But the problem here is people speak different languages, look very differently, live in different houses, and 1.4 billion people, at least in India. But they also live in millions of square kilometers, which also brings in the mobility problem. When we go to a person's home, there is also another component that actually comes in, which is not just the disease, but also the determinants of disease, the cause of disease. And if you look at any disease, it's actually a combination of where you live, where you work, and what you do in between. And if I want to perhaps manage the disease, I not only have to treat the disease, but I also have to look at the cause. That's when I really manage the disease. It's realistically not possible when you come to a hospital because, as somebody mentioned, when you walk into a car showroom, you are more or less 70% decided on what car you are actually buying. Same happens in disease also. When you walk into a hospital or a clinic, more or less 70% or 80% of the disease is already there in you. And that's when you realize that you are actually suffering from a disease. So when I go to a house, I get the additional data point on where the disease is actually developing, how it is actually developing, what you are actually doing, and none of this is actually captured now. And that's the challenge that we are actually working with. I'll give you two use cases, perhaps things that actually work on the disease side, determinant side, which was not working before at all. Number one, now you have continuous glucose monitoring, but you also wear Fitbit kind of devices. So a combination of it, a lot of people are now able to control blood sugar, which previously was only because of medicines. Now with a combination of exercises and also tracking continuously are able to do it. We were doing some field service, or rather we actually rolled out our software in Bihar. We screened 500,000 people. A lot of them suffer from elephantiasis, which a lot of people would have actually forgotten. Your leg actually swells up pretty big. And what we even saw was that if you are able to identify these people, tell them what to do, follow up every 2 weeks, and after they continue with the exercises and wound management, we are actually seeing remarkable changes to a point that nobody ever thought this could actually happen, which is disease reversal. This big leg coming this small, and people actually coming to us and say, hey, I'm able to wear a jeans. I mean, this is disease reversal for us, but a social change for us. Women coming forward and saying, I'm able to wear anklets. Never happened before. And this was never happening at all. So what you actually see is these continuous granular measurements followed by continuous interventions over a period of time is actually bringing in results. And this is also happening at the determinant side of it. Now, again, we went to 500,000 houses, and then we told them, there is garbage lying around, there is actually water stagnation lying around, and we told them what to do, which is fairly very simple. Everybody knows about it, but in a customized way. And some of them actually did. Substantial people, seeing them, actually followed it up. And 2 years later, we are seeing a substantial reduction in cases of dengue, chikungunya. And these are things that are actually happening. And as some few gentlemen actually was talking about it before, there are a lot of these things possible in healthcare and education, but the challenge here is no data. And even generating this data, collecting this data, identifying what to collect, how to come out with all these changes, needs to be really thought out in a newer way. And that itself is fairly a challenge. I mean, your intelligence exists, your technology exists, but connecting them to the use case, understanding the context, and figuring out how to bring all these things on board is a serious challenge. But if it happens, you actually see changes. And these are some of the areas that we are actually working with, and I'll leave it to the others to follow up. Thank you very much.
Thank you, Dr. Suresh. And move on to Sunil, right? One thing we have seen over the past 5-6 years is the number of sensors embedded in essentially everything, whether it's your watch or other things. So non-invasive measurement of your healthcare parameters is one big area, right? And Sunil has been doing pioneering work. Sunil.
Thank you, Verma. So I've been listening to the other panel as well, where everyone is very much quoting on how important the data is for the AI models to actually run. If I have to give an analogy, it's more like a mind that is without 5 senses is how AI looks like without the data input. In fact, particularly around the product IVA that we have built, exactly caters that need where, so far people have been alienating AI to only larger organizations, though AI is something that has already penetrated into our day-to-day homes. What we wanted to do was, with our product, we wanted to bring data, analysis, and decisions, all of them together. A person can't take holistic decisions unless they continuously keep understanding how they are doing on a day-to-day basis. And without that data or without that additional input from either sensors or body analyzing devices, it's more like a AI model on a synthetic data, which might not be relevant every now and then. And at the same time, an end user might not be able to rush to a hospital on a daily basis trying to understand their day-to-day lifestyle. Here, what we are trying to do is how AI can help an individual to take lifestyle decisions within their home by understanding more about themselves, if I have to say, by bioexperimenting more and more with themselves. Here, since there is an use case, our end users are more happy to feed the data or collect the data through our gadget so that we are able to give them better decisions so far.
Thanks, Sunil. Moving to Dr. Kalyan, right? One other area where a lot of work is happening and a lot more work will happen in the future is in terms of genomic sequencing, right? The price of sequencing has come down so much where we'll truly get to personalized medicine. We're already there to a certain extent, but we'll get to a point where everybody can get very specific diagnosis and intervention, right, for them, right? Dr. Kalyan is doing, I think Hyderabad probably is there the first one, right? Let him talk more about it.
Thank you, Verma. Thank you for the opportunity. So I would start with saying that I am, in terms of healthcare, I am in the most exciting field in terms of gathering data, analyzing the data, evaluating the data, and then using the data. So really in real time we are using AI ML models, and we have a beautiful scientific team. But I will start with a simple statement that I just saw. Even the previous members also touched point upon this. So it is a very beautiful statement. Oil is not the used case. Driving a car is. Electricity is not a used case. Reading at night is. So we should answer the first question, is AI really the used case? So what is it we are trying to solve in health when it comes to using the AI? So we need to have a very clear, when it comes to health, what is that we are trying to solve, and then create a model where AI can help us reach there fast. That is my understanding, because I'm not an ML expert, I'm a physician, as he mentioned, but for me AI is really an advanced statistics model. That is my understanding. I don't mean to be generalizing, but that is what I mean. Coming to this question of multiple people analyze the same thing, data. So what is clean data, and why as a country we are lagging behind in gathering this clean data? So any model you can apply on the data, and then it shows out results, and you see in terms of researchers here, there, you will get some thousands of significant p-values, and then you go back and see what it means when it comes to the data. So this is not how research should work. We need to have a very clear vision of what we are trying to look from this data, and then the most important point is having the clean data and then sharing this data. When it comes to any other field, sharing data is not having a lot of ethical consequences. But coming to health, there are a lot of ethical consequences, the identities, the personal histories, the insurance, a lot of things. So there has to be a governing guidance towards it, and then there has to be an regulatory body who says that we are going to collect the clean data, we are going to make this data available to every startup in health. So there is a lot of hype in data. So just to give an example about computing in genomics. So if I sequence genome of each and every person here, I'm talking about whole genome, even though we do it at least depth, it will give a data of 150 GB. And if I go to a next level and I sequence the RNA, it will give another 80 GB data. And then if I go a layer beyond and do a proteomic, which is complete protein sequencing, it will give me another 200 GB data. And then if I go a level beyond and then take all the metabolites and measure them, it will give me another 80 GB of data. So each person, if I do complete sequencing at a genome level and then try to analyze it, it is 500 GB data per person. And this is only a raw data. Once I try to analyze it, the multiple layers behind it, it will go all the way to 1 TB per each person. So this kind of computing data, and then this is not a one-time thing. We have to do it multiple times over the time. Sorry, I did not mention the microbiome. Microbiome is another 100 GB added. So if you add all this data, each person will develop around 600 GB of data, which will go around to 1.2 to 1.3 TB. And then how do we apply what we need to find? So for example, if I want to say, I want to identify the person having a cancer 3 years prior to it happening. That is the researcher side of me. And I am very excited. I see the results. Okay, there is a metabolite, there is a protein change. This guy is having some changes which will make him predisposed to cancer 3 years back. And when I come back and put my physician hat, what I'm going to say to the patient? I know that you are developing a cancer. I don't know where it is. I don't have any modality to screen for it, but I know that you are developing cancer. So this is not how the practicalities will not work. So it is not just the health data, it has to be the technology we should develop. We should go deep into identifying these imaging modalities which are going to detect these lesions once we identify there is a risk pattern. So this is all evolving field, and so many exciting things in health are going to show up in the next 10 years, I'm sure.
Thank you, Dr. Kalyan. Maybe I'll just add a little bit there, right, before we get to Dr. Nitin, right? I mean, all the other speakers talked about a lot about data. Dr. Kalyan talked about too. This is especially acute in the healthcare field, right? I'll give you one small example, right? Since we talked about genomic data. If you see publicly available genomic data, because this is, I mean, we're going to use genomic data to give very specific personalized diagnosis to patients, right? And if you're going to develop a solution based on the data, that data better be good, right? If you see publicly available genomic data today, 99% of it is actually a Western population, and specifically white Caucasian population. Now, how are you going to use that data and develop a model for Indian population? Absolutely not going to work, right? So we have to have very good curated data for Indian population data sets before we can develop good models for our population, especially in healthcare, right? Now I'll go to Dr. Nitin, who's going to talk about his views and as a practicing, right, clinician, right, how they're using AI in their world. Go ahead, Dr. Nitin.
Thank you. Can I get my slides? So till now we know that majority of models are wrong, but we need to find which model is good for us, and whatever machine is nothing but does that machine makes my life simple or my patient's life simple. So what is problem for us? All Western countries recommend screening colonoscopy to detect pre-malignant conditions above age of 50 years. And because of huge Indian population, we don't have that program. And colorectal cancer is third most common cancer in the world, and even in India also. So this is the problem statement. Even if you consider just withdrawal time during colonoscopy at 6 minutes, and unfortunately we don't have 10,000 dedicated colonoscopes, then only we can match the time within 1 year. So this is practically not possible to screen all person who is above 50 years for detection of early colonic cancer so that we cure that disease at early stage. So what we did this simple study to see how many colonic adenomas are there in Indian population. As compared to Western population, the prevalence is lesser with us. It's around 20% in Indian population compared to more than 50% in Western population. So we did routine regular analysis and find that area under curve is around 60% with logistic regression. So we took help from some of the people and we developed machine learning model with this features, and we could find out that few of the machine learning models perform better than regular logistic regression model. So we're trying to validate this model in future with new subsequent prospective data. He did some optimization on this model, and then area under curve has reached up to 92%. This is not end. There are two types of polyps. One polyp which has a higher frequency to develop into cancer, which is called adenoma. And another polyp which is, can I play this video? Sorry. And there is another polyp which is non-neoplastic or hyperplastic polyp. That usually don't turn out into the cancer. So if we do more colonoscopy, we will find out polyps which may not have a malignant potential in future. And this is one of the software developed by a company which we evaluated at AIG, which is called EndoBrain, which real time can detect and show on the screen to the colonoscopists whether this is having potential of neoplasia or not. And there is some glitch in the video, but what we can find real time is whether there is a chance of having malignancy in future or not, and that can be detected on site during the colonoscopy. It's okay. Another problem is many of the people have gallstones, and they tend to develop CBD stones. That is one of the complications of gallbladder stones, and the CBD stone can be fatal in particular patients. It can develop jaundice, fever, cholangitis, infection, etc. So along with John Hopkins, USA, we studied this model. There are few guidelines which recommend how to treat and how to evaluate these patients. And when we compared all other guidelines, ASG stand for American Society and ESG stand for European Society of GI Endoscopy. And these guidelines also gives area under curve around 60-62%. And this gradient boosted model gives more area under curve, which can be more specific and can reduce unnecessary investigation and unnecessary test or treatments for these patients. Thank you. Healthcare is something like that gold mine. We have a great data which is not used till now. Thank you.
Thank you. Maybe I'll follow up with you, right? I mean, you've shown a couple of examples. Are these advancements in AML helping you to be more efficient or helping you to do new things that you couldn't do before at all?
Yes, definitely. It's like last slide what I shown, that there is chance that 20-30% of patients get that test when actually this is not required. So we are reducing the burden, healthcare burden we are reducing. Also for this colonoscopy study, there is a fair amount chance that we can reduce the healthcare burden and unnecessary hospital visits.
Same question to you, Dr. Suresh, right? Are you able to do things that you couldn't think of maybe 5-10 years before?
Absolutely. I mean, two big challenges for primary healthcare: awareness and access. We cannot expect people to be aware about 100, 150 diseases, identify the signs and symptoms early, walk into a hospital. That's not possible at all. On the other side, you cannot have one doctor per so many people available in each and every village. That's also not possible. So you have two challenges, awareness and access. The only way that is even possible is perhaps screening these people early. So I need to upskill people living in the villages who may or may not even possibly be educated, or their education levels are going to be fairly very less. So what we actually need is perhaps a human being who can access the people, but who is equipped by the intelligence with the softwares and with the devices that we are building. But the use case basically is identifying the diseases early and also being accessible close by. So this is possible only with technology, as a co-pilot or as a kind of a prompted service, or as perhaps somebody who can actually be upskilled. So going forward, the way that we are actually seeing is there's going to be this so-called upskilled person who actually has access to the global intelligence, but contextualized to the local environment, but who can answer the questions that are being raised locally, but also guiding this person locally to a point that you can actually live a normal life. And normalcy again is a kind of a wide boundary, but then it can be contextualized to this person. All these things are not possible in the present analog system or the analog process at all. We are now reaching 8 billion and possibly we'll reach maybe 9, 10 billion very soon. And at this kind of scale, it's impossible for the present analog systems to cope up with whatever you would actually want to do. So the only way forward is through intelligent systems which can also work in the local environment, in the local context. And that's the challenge that we need to address.
Particularly around non-invasive blood glucose. What happens is when the sensors look through your skin, it's not just glucose that it starts seeing, but it starts looking at 120 plus other variables in real time. And most interesting thing, while we are sitting on close to 2 million data set, what we clearly observed was every individual data that our sensors reads were pretty unique. As you rightly mentioned, right, the Caucasian data that has been there, the Mimic2 database that is widely available, became as good as useless to us. In fact, when we put our product on field and try to understand how our sensors look at the data, we usually give this analogy within our company that looking at non-invasive blood glucose is like trying to find a needle in a needle stack. So we were literally comparing so much of data that we have and trying to understand the glucose variable, which is 0.4% of the entire data that we are seeing within those 60 seconds. For an individual looking at 120 plus variables and counting, and looking at millions of data set and trying to understand glucose is close to an impossible task. This is where AI/ML really helped us in defining our technology itself in the first place. Though we spent around 7 years in building this particular technology and further improvising on it, but last 2-3 years we were able to tremendously add more and more inputs to our models. Another thing that we also realized, particularly around healthcare, when we are trying to understand glucose and blood pressure variables, is the environmental impact of the environmental impact on our end users and their vital changes. For example, we observed very different data set in winter compared to summer. We also try to understand a lot of people, a very misconception. When people think that when they work out without having food, they'll shred faster and they'll be a lot more healthier, which is an absolute misconception, because your body is working very different when you doesn't work out, when you doesn't eat and work out. Your glucose tends to spike a lot more. Your metabolism tends to be little slower than what it actually is supposed to be for people who are planning to be fit. So this is just one example of few celebrities with whom we are working in best possible muscle shred and recovery, particularly using AIVA. This is one area where we use deep AI models with inputs from our in-house doctors and our multiple research that is available across the globe. Apart from that, the second point is generative AI assisted decision making. So, for example, we are introducing one model where I can take my phone and say, hey, what should I have for breakfast this morning? My app should be able to tell me what kind of portion of carbohydrates or protein that I should have based on how my vitals have been performing in the last 1 week to 10 days. That is purely because we are able to feed all this data along with activity log to our systems for customized curated insight. The AI that I have in my phone is absolutely curated to me based on the data that is coming from the sensors. These are the two areas which shouldn't have been possible without AI ML models.
Thanks, Sunil. So on the same vein, Dr. Kalyan, right, he talked about a device personalizing, right? You work with multiple data sets, right? When you talk about personalized medicine, there is, the sensor data, there is the radiology data, pathology data, genomic data, right? I mean, multimodal data, there's a lot of multimodal data. How much do you look at all these things today, and where do you see that going?
Yeah, we work with multi-modal data. So again, the model that we created is for each condition. So we don't want to run the whole data into everything, and then so we are very specific in how we try to use the technology. So again, we go back to the question. So this person has so and so in the family history, so and so in his blood work, and he's worried that he's taking so and so medication and it is not working for him. So we come up with the question and then use this data, how we can answer that question. Is it the right medicine? Is it the medicine you should be taking medicine or not taking medicine, or what are the things? So we come up with questions and then look into this data. So that is how we were able to come up with answers. And I will again just point on the point that you made before, that most of the data available is Caucasian. And it is for a good reason. Without NHS,
they put in the more money first.
Yeah, without NHS spending that kind of billions of dollars into the research, there is no reference genome, there is nothing much. And ironically, what is happening is even the cost of computing came down to low, and then the cost of sequencing came down this low. Even then, we are not adapting. That is what bothers me as we go. So we missed the first evolution of groundbreaking science developments. So we ended up just doing generic medicines APIs rather than inventing new pathways and discoveries. Again, we are missing on the second boat as well, where we are not coming up with cutting edge researchers. Again, we are, if we just wait for Caucasians to develop something and then we follow, the data will be Caucasian. So we need to develop these sciences. So if you know any medicine that you are taking right now, they are not tested on us. So we do it as phase 4, and then we start taking it, and then the data comes after 10 years. And there are at least 90 medications in the last 20 years which were removed from the market from Indian because we found out that they don't work in Indian population. So it is going to happen again. So this is the time that because of the technology that we have, this is because of the development teams we have, that we need to generate this quality data and then showcase that we are also into. And on that same note, I want to also mention that There is a big hype about the generative AI coming up with drug discovery, and then they're going to come up with AI/ML giving a drug molecule which is going to be a targeted medicine. But so far, none of them worked.
Yeah, I mean, on the generative AI, I mean, already everybody is a Google doctor, right? When we go to a doctor, we Google and then we tell the doctor. Now with generative AI, we'll do the diagnosis ourselves and go to the doctor. So I can see this thing, not helpful at all to the doctors, at least for now. Maybe it has to evolve, right? Following up on what you said, right? I mean, ultimately with all these AI models, right, and all these multimodal models, I mean, we want to get to a state where we want to predict, right? I mean, if you see the disease burden in India, right, CVD, diabetes, and cancer are our top three, right? Almost everybody knows somebody in their family or friends who is impacted, right? So, I mean, ultimately, we need to get to the point where if we can predict these 2 to 3 years before the onset, I mean, that's the real value, right? Do you see us going in that direction with what you see?
Yeah, absolutely. Absolutely, we are heading in the right direction. Fortunately, what we saw in the limited data that we produce, it is almost in multiple TBs right now. But we are not as diverse as Caucasians. So we are very inbred population.
We are not. We are told that we have a lot more diversity than other countries.
No, we are very inbred population. So in such a way that really these models, what they are trying to develop, will really work very well in Indian context than in Caucasian concept, because over migratory population migratory mode, there are a lot of multiple diversities which are in the data sets in US compared to the data sets which we are finding it here. And also with the CVD project that we are doing, even with the sample set of 2000 or 3000, we are able to see there are multiple correlations which we can build up. So imagine that we really scale it up to some 1 lakh or 2 lakh people. We can really put it into population perspective. Who are these people who are at risk, and who are these people we should screen? Who are these people who should get? Again, I want to emphasize on Dr. Nitin's statement that not everybody needs to be screened because it's cost prohibitive. We need to identify who are these people who will benefit from early intervention, and these are the things, because we are youngest population. If we don't do anything now, what happens after 25 years? So that is what, again, the point being is how do we get this predictive, preventive medicine into the market? And again, Dr. Suresh mentioned the primary healthcare, the way that it is happening in India. Even in our study too, at least 75% of people who we said that your HbA1c levels are diabetic range, they don't even know until we draw the blood. So it is new diagnosed, 75%. So this is the kind of structure we are dealing with. So there needs to be more pure data where we can really apply these models, where we can come up with proper predictions at a population level.
And this needs to be more at the primary healthcare level, right? Maybe Dr. Suresh can add. I mean, if you go to, just to go to an example, if you go to AIIMS Delhi, right, the first time I went there, the OPD deals with 10,000 people a day. It's huge, right? And a lot of the people, by the time they come to the secondary and tertiary hospitals like that, they're already in stage 3 and stage 4, right? So if we can really get to preventive medicine in the primary healthcare, it can really have a big impact. Dr. Suresh.
Thanks, Verma. I mean, all the 3 disease conditions that you mentioned does not happen overnight. It takes 10 years, 15 years at least to develop. And you can look at it in 2 ways. One is I kind of reduce the severity of the disease, which happens in the last 30% of the disease development, which is where you are perhaps looking at now. Or the other way around is I keep the person normal where he does not actually develop the disease at all, which perhaps happens in the first 5 years. And the second part that I actually told is not at all possible today. It's not possible with the present way of looking at the disease. And that's where I think AI would actually come in where every day it will give you fairly a band of things that you can actually do, where you won't end up with the disease 10 years, 15 years later. So that would be something that is perhaps like completely a game changer, or perhaps things that we can't even imagine at the point now, and that's what we should be aiming for. Perhaps the present way that we are looking at is how do we identify the disease early and slow the reduction of the disease, which I think is the present way of doing things, but we need to look at it on how to keep people normal, how do you completely come out with a customized way that fits in with your lifestyle, fits in with your location, fits in with what you would actually want to do, and still not kind of get into the disease state maybe 10 years, 15 years later. But this is where diversity actually plays a lot. I mean, I would not want to get into the lack of diversity at the tertiary level, but at primary level, God, we are very diverse. I mean, whatever you eat, whatever you do, whatever you kind of think about just keeps changing from every person. There's too much diversity in our country, which is perhaps good at some point in time.
Yeah, I think you operate across India, so you see the diversity firsthand, right?
Thank you.
Dr. Nitin, anything on the preventive medicine at the secondary and tertiary level, right? What can you do?
So you mentioned about 3 diseases, which is cardiovascular disease, diabetes, and cancer. And maybe all 3 are related to one aspect, which was one of the feature in our model for colonic polyp, which is metabolic syndrome. And it's nothing but a conglomeration of diabetes, dyslipidemia, obesity, etc. And for that prevention, AI may not be required unless until you are too much on Netflix, and you need to avoid AI in that place. So, because you need to be more active for that, and for that something like app which monitor your vitals, whether it's saying that your exercise, when you're doing exercise, does your heart rate is getting up to 100 to 140, that is required for something we call as moderate degree exercise, whether your other vitals are synchronizing with us, with the data and all these things. And the most important problem for current era after other communicable diseases is non-communicable disease, which stands out is obesity and metabolic syndrome. And for that, we need to uninstall majority of app which is using AI, such as Swiggy, Zomato, Facebook. I personally don't have these apps on my laptops.
I think
we are now getting into good AI and bad AI.
Yes, we have not discussed that there is much more effects of AI that are beyond the subject of healthcare also, which is going into our day-to-day life. So if you see obesity as a disease, I'll start that obesity started when a normal animal named Homo sapien has started agriculture. And then we came to the industrial evolution, then IT evolution, and now we are reached to AI evolution. So this disease is not for 1 decade, 2 decades, it's evolved over a generation.
Yeah, I mean, we are what we eat, and there is a lot of actually work that happened in the last 10 years on the gut microbiome, right? I mean, it's almost like a second brain, right? So actually, there's a lot more data coming out, right, which will tell you if you handle that part, all these other diseases, right, are a result of not taking care of your actual intake first, right? We got 4 more minutes, right? Maybe I have one more question on regulation. And audience, if any question, right, please ask, right? And recently there was this data protection bill, and then all the speakers talked about privacy and bias and all this, right? The data regulation bill seems to be going in a right direction, right? How do you see? Maybe I'll start with Sunil, right? You have a device, I think you're probably more impacted than anybody else first.
Yes, absolutely. In fact, when we are collecting this kind of data on a day-to-day basis, particularly our gadget, IVA, collects that data on an average at least 10 times from each user. We made a behavioral shift that way there. Whatever the AI for good, that's what we are able to decently achieve from 1 time a day to 9 times a day that a person is able to understand their health more and more better. While we are doing this, as a health tech and responsible company, we also have to make sure that data is absolutely masked. No individual will be able to link the data to any unique identifier. While we are doing this, and at the same time, we also need data from the user that is very specific to them for us to be able to give right and more better insights for them. So in fact, HIPAA has certain guidelines around that. Similarly, GDPR, the same way. I'll give a simple example when we are talking of security. I can't ask my user what's their date of birth. I can only ask my user what's their year of birth. That kind of dilutes the data sensitivity. Similarly, I can't ask my user what's their exact height is, but a bracket of height is. So that way you can dilute so that you can...
Is there HIPAA regulations?
It is HIPAA regulations, yes. Similarly, we can't store all the data at the same location. We can't have the PMF data, that is personal identifier data, and the raw data that is being collected from an end user and the analytics at the same location. For that, we have to do data sorting algorithms, which have to pick each data from different sources and have to bring to the end user the moment they click within 200 milliseconds. So AI and security both have to go hand in hand.
Medical device is more stringent, but coming to healthcare, one again, we only talk about HIPAA and GDPR. There is at a genomic level, there is an US GeoPast, which is Andhra, I don't remember the name, but so what it exactly means is only one user need to identify. There is an complete structure. I think it is given by GIST, that is the governing body in US, who gives the data security coding for all these measurements, and we follow the same thing here. And I have been hearing that Indian government is going to come up with their own data security policy, which might happen next year. But having said that, these protocols are very important to follow, and any Indian data, which is even at a genomic level or transcriptome level, should be stored and analyzed within the territory. So I think that is the reason why most of the cloud spaces are installed in every place. If I am working with any genomic data from a Dubai sample, I have to open that server in Dubai and then use only that server. I cannot download it to physical server here. It's the same one. Any company which is trying to go globally, they need to have an idea about what servers are in which place, and most of these AWS, Azure, they have their servers in every country available. But having said that, in India there are still the insurance companies cannot have access to this personalized data unless there is an verbal and physical consent given by the end customer. It is happening in US, but in India it has to be really enforced, and the decisions cannot be made depending on their genomic data, because right now we do not have any conclusive evidence to say that this person is going to develop this disease at this age. It is still very premature. They can have access to electronic health records, but not the genomic data. So that is where we are right now.
Yeah, and also we have a unique ecosystem in India. We need to sort of take advantage of. I mean, if I compare, like say, US and China and India, three big economies, right? I mean, US is mostly driven by the private entities, the regulation, and China is China. The government does everything, right? Nobody has any say. I mean, India is the one which is right. We have the biggest population. That means a lot of data, and we have the industry, government, and academic who can really collaborate and actually take advantage of it and do a lot more than any of those other entities can do, right? So our regulation has to sort of take that into account, right? So I think we're almost out of time. Any questions from any audience? Or you'd already go to lunch? Please. Mic, please.
Hello, audible? Okay. Well, you pick who answers, but this is my question. Not within you being dignitaries or some public position holders, just as a end user or a consumer of AI, what is that one single benefit you want AI to pass on to you as an individual?
Maybe each one of them can actually give their own perspective, right? Yeah.
I already said about it that it should make my practice simple and end point for my patient should be better. So he should not have unnecessary side effects, he should not have unnecessary tests, and he should get better treatment within a particular time. So that's what I want.
So from my side, I want people who think exactly like me to come and meet me so that we can make an consortium and make a case.
So here, in my perspective, whether someone want it or not, AI is going to be there in our day-to-day lives. The one thing I want AI to be part of my life, or particularly my life, is it has to help me bio-experiment and understand more about myself so that I can take better decisions.
Suresh?
Yeah, AI for me is from 10 steps to 3 steps. But it should also stop when I say stop. And that's necessary.
That is the difficult part. I think we'll take one more question and wrap it up. Yeah. Srinivas garu.
I think, Varma, I know you're doing a lot of work at the primary healthcare level. I think the concept is all about preventive healthcare. So where are we today? I think with about 700 odd districts in India, and then close to about 250,000 gram panchayats, and 677 lakh villages, right? What's happening today from the government side? Technology, obviously, when it is done at a rural level, is where we'll see a positive impact. On the preventive healthcare side.
So Suresh was my co-conspirator. I'll add a little bit and he can talk more, right? I mean, the two aspects. Actually, the government has done a decent job with the Ayushman Bharat and the Ayushman Bharat digital mission, right? To have a really good architecture so that we can all plug into it, right? I mean, if you see the US system, right, it's very sort of a legacy and you can't really change it. That way, we really have a new architecture that we can plug into and really well defined. And government is sort of learned this from the UPI and other architectures and roll this out, right? That's the architecture side. Then comes to the actual deployment of these applications and developing them and deploying them, right? I mean, Suresh can add more. They have done the development and they have put a lot of effort into it. Now, this is what he's been doing for the past 3-4 years in terms of deployment. That's where the toughest part is, and he can add, right, the challenges there.
See, there are 2 challenges. One is regulations and diversity. If you look at tertiary healthcare, what works in US, you cut paste it, it works even better here. If you look at primary healthcare, unfortunately, we are on our own. We need to understand what is the local ecosystem, what is the local needs, and come out with technologies that actually address these local needs. Healthcare as it is, we simply import or assemble and then deliver the services here. And there's actually a long way to go when you're looking at primary healthcare. And this is where all the complexities are in the diversity and also in the understanding. And the third part is a very complex situation that nobody knows what's the answer, who's going to pay for it.
That's the toughest part. Okay, thank you everybody. I think it's been a very wonderful discussion. Thank you all.
Thank you, everyone. This is a very special session with real-time feedback from doctors. We live next to AIG hospitals. Once My mother required some appointment. I tried for Nitin Jagtap's appointment, and the reply came that after 1 week. Then I told we stay next to AJ hospitals. It will still 1 week. It's yeah, I think he's very senior consultant, and like I got to know about him later, and very glad that we have him in the panel today. And thank you everyone in the panel today. And may I request Mr. Varma Konala to felicitate our panelists. Now may I request Mr. Hariom Pandey to felicitate Mr. Varma Konala for leading this session. We can have one group pic. We'll break for lunch now. It's 45 minutes. Let us meet after 45 minutes. We have one more interesting session from